Hello, my dear students and the serious GATE 2026 aspirants. How is your preparation going on? I hope it's great, right? But don't give up, sir. The suggestion I give as a faculty in ACE Academy and ACE Online, never give up until the last second you come out of the exam hall. Until then, never give up and don't think that you did not complete this, you could have studied better, nothing to worry. Until last moment, don't give up. I hope your preparation is going really well. All the best. Now here, myself, B.S. Krishna Verma, faculty in ACE Engineering Academy since 2009 and ACE Online. Here we are providing solutions to pre-GATE 2026 electrical engineering. See, it's a real-time experience to conduct such great exam. And you know, it requires lot of effort, lot of resources, lot of money, etc. And ACE Academy is never going down in this regard. And here a team of faculty with real-time experience of more than 15 years or more than 300 batches together, we are giving such accurate paper. It is a real-time simulation of what you really feel when you write GATE 2026 paper. The standard is accurate. The average division of marks is accurate based on the last 6 years what we took. So I hope this solutions will help you to learn with accuracy. And it really simulates whatever rank or whatever score you get in this pre-GATE from ACE Engineering Academy and ACE Online. It really almost simulates to what you can expect. Okay, maybe plus and minus 10% tolerance, I would say. Yes, myself, B.S. Krishna Verma, faculty in ACE Engineering at ACE Online, and this is the solution for pre-GATE. But before I give solution, I want to talk about what are the parameters we took in conducting such great exam. Now, you know, the question paper has 65 questions, 3 hours, yes or no? Now, it has got 3 important patterns of questions, which I want to highlight. Now, GATE would contain questions of 3 different types in all papers. MCQ, multiple choice question. Yes, you know, you have to tick only one correct answer. And if it is wrong, you know, there is a negative marking of 1/3. If it is a 1 mark, 1/3 of it is 0.33 marks. If it is a 2 marks, yes, 1/3 is 2/3. Okay, yes, you know that 0.66 marks. Then numerical type answer NAT. Okay, here accuracy up to 1 decimal or maximum 2 decimal places he asked. Only once he asked 3 decimal places, but otherwise generally accuracy up to 1 or 2. Here purely mathematical type. Okay, you have to type the answer. And multiple select question. These are the recently introduced, and you know there are multiple correct answers. Of course, we will discuss about them. Now in MCQ, yes, multiple choice questions carry 1 or 2 marks each in the papers and sections. These questions are objective in nature. Each will have choice of 4 answers, out of which only 1 choice is correct. Native marking for wrong answers, and for wrong answer chosen in MCQ, there will be a native marking. For 1 mark, it is 1/3 deducted, and like for 2 marks, 2/3 is deducted. Okay. Then numerical NAT. This is what is challenging, sir. GATE is highly numerical paper. Numerical type answers, NAT questions carry 1 or 2 marks here also. Each in most of the papers and sections. For each questions, the answer is a signed real number, either positive or negative real number, which needs to be entered by the candidates using the virtual numeric keypad on the monitor. Keyboard of the computer will be disabled. Okay. No choice will be shown for this type of questions. The answer can be somewhere like +10 to -10 or an integer. It can be any range. It can be 234 ohms like that. Okay. Then the answer may be in decimals as well. For example, 10.1 1 decimal, 10.01 2 decimal, or -10.001 like 3 decimal. I had never seen 3 decimal, but accuracy up to 2 decimal places is recently mentioned every time. Okay. Then MSQ. These are the recently added. MSQ multiple select questions carry 1 or 2 marks each. The paper and sections, these questions are objective in nature and each will have choice of 4 answers, out of which 1 or more than 1 are correct. Even all 4 can be correct, 3 can be correct, 2 can be correct. It depends. There is no native marking here. Of course, there is no native marking for the wrong answer in NAT and MSQ questions. So yes, in MSQ and NAT, there is no native marking. Please understand. However, there is no partial credit for choosing partial correct combinations of choices or any single. Okay. So in NAT also what I told, if you write wrong, there is no marks. But yes, here native marking is not there, but you will get 0. But here, yes, in MSQ also you have to select all the possible options. Now again I always mention, though we are giving this pre-gate question paper with very accuracy, as a team of most experienced teachers together gave it, sir. Let me tell you, like I myself in electric circuits or networks, but a team of teachers together gave this paper, let me tell you, and with most experience to simulate what accurate way you can experience and feel about GATE 2026 paper. Now, which is the most important subject? My question is this: what is your answer? All. Okay, though weightage depends, it can be, okay, it can be up and down, we cannot guarantee anything. My subject sometimes came least 6 marks and sometimes it came 17 marks, let me tell you. Like electric circuits for EEE, least came 16, highest came 17. Okay, sometimes signals came more than machines. We cannot guarantee anything like that, but based on the averages in the last 5 to 6 years I gave this paper, every teacher has followed that distinct rules. And but as a preparation, which is the most important subject, what is your answer? All. Okay, all, sir. Even a simple subject like mathematics or measurements will make a difference, so don't give up. All subjects are equally important, and in each subject, which is the most important topic? For example, in electric circuits, which is the most important topic? Is it transients or two ports or theorems? All. Again, my answer is all. So that is a mindset you should have. Balance according to the weightage and capability of the subject, but all are equally important. Now, this is the weightage I want to highlight. See, in preparation of this great question paper and pre-gate, okay, this is the average we followed, okay, since 2021-25, last 5 years, okay. Based on this average, yes, this is the average accurately for GATE electrical engineering paper. Okay, let me come that side. Okay, so this is the average. So we followed this average, okay. Electric circuits and fields, okay, and control system, signals, analog, digital measurements. These are fundamental common subjects. These are core electrical engineering subjects. Even I would like to mention that electrical measurements comes under core, of course, and this is max and general aptitude. Okay, so you can look, you can I will move out, you can take the screenshot of this slide and look at the averages. Okay, so based on this we prepared the paper accurately. Then yes, that is what I want to again highlight in preparing our pre-gate accurate paper. I classify GATE question paper into 3 categories: aptitude engineering max, around 25 to 30 generally, okay, of total marks. Fundamental common subjects, as I told now, sir, fundamental common subjects, okay. Okay, fundamental common, they may be common with EC and instrumentation, okay, 40 to 40% of total marks. Core electrical engineering subjects 25 to 30. But to reach there, you need engineering max, common fundamental subjects, and then core subjects, okay. But balance everything based on its weightage and its depth and vast way of exploring the knowledge. Like power system may take more time, machines may take more time, okay. Balance according to that. Then percentage of weightage of numerical questions is 80 to 85. So overall, whether it is MSQ or MCQ or NAT, overall GATE paper is a numerical paper, okay. He will not ask theory questions, please, but still some 15 to 20% you can expect theory, but overall 80 to 85% or more than that is always a numerical, okay. Electrical engineering is max, sir, okay. So GATE paper is highly numerical with lot of applications, okay. So that is what I would like to say. On this basis we prepared the question paper. Now we will start the solutions for each subject, okay.
Pre-GATE 2026 common topics of engineering mathematics we discuss. One more question: if capital A is a 5 by 5 matrix such that A cube equal to 0, then the number of non-zero eigenvalues of A is, and you have to remember that if A cube, here order of the matrix doesn't matter, either it is 2 by 2, 3 by 3 or n by n matrix. If A cube equal to 0, A is a nilpotent matrix of index 3. All eigenvalues of nilpotent matrix are zeros. So number of non-zero eigenvalues only 0. Because A cube equal to 0, A is a nilpotent matrix of index 3, all eigenvalues of nilpotent matrix are zeros. That's why number of non-zero eigenvalues of matrix A is 0. How do you know that? Here A cube equal to 0. If lambda is an eigenvalue of A, then lambda cube is an eigenvalue of A cube. So replace A cube by lambda cube. Lambda cube equal to 0. Lambda cube equal to 0 means lambda equal to 0. That means all eigenvalues of the matrix are zeros. And you observe A1, A2, A3 are 3 events such that P of A1 equal to P of A2 equal to P of A3 equal to 1 by 3. and P of A1 intersection A2 and P of A1 intersection A3, P of A2 intersection A3 equal to 1 by 6, P of A1 intersection A2 intersection A3 equal to 1 by 6, then the probability that none of the events of A1, A2, A3 occurs is, none of the events occurs. So, first of all, let me find probability of occurrence of an event at least once. Probability of occurrence of at least one event occurs. Do you know at least one event means P of A union B union C? That is P of A union B union C means A1 union A2 union A3. So P of A union B union C equal to P of A means P of A1, P of B means P of A2 plus P of B, that is P of A3, minus P of A1 intersection A2. This is A1 intersection, A1 union A2 union A3 means probability of occurrence of at least one event of A1, A2, A3. So this is A1 minus A2, A1 intersection A2, A1 intersection A3 minus A2 intersection A3 plus P of A1 intersection A2 intersection A3. Do you know, here you remember P of A1 value, you observe P of A1 value 1 by 3, P of A2 value 1 by 3, P of A3 value 1 by 3. So, P of A1 value 1 by 3, 1 by 3, 1 by 3. So, therefore, it is 1. Next, P of A1 intersection A2, P of A2 intersection A3, A3 intersection A1, all are 1 by 6 only. So, therefore, it is 1 by 6 minus common I took 1 by 6 plus P of A1 intersection A2 intersection A3, which is also 1 by 6. So, plus P of 1, this is 1 by 6. So, 1 by 3 plus 1 by 3 plus 1 by 3, that is 3 by 3, that is 1. Minus, that is 3 by 6 means 1 by 2 plus 1 by 6. 1 minus 1 by 2, that is 1 by 2 plus 1 by 6. 1 by 2 plus 1 by 6, that is 8 by 12, or if you take LCM, 3 by 6 plus 1 by 6, 4 by 6, that is 2 by 3. 2 by 3. Probability of occurrence of at least one of the events A1, A2, A3 is 2 by 3. But we were asked to find the probability of none of them occurs. None of them occurs means probability of none of them occurs means 1 minus probability of at least one event occurs. At least one event occurs. 1 minus probability of at least one event occurs is 2 by 3. So 1 minus 2 by 3, that is 1 by 3. So do you have an option of 1 by 3? No. It is a fill in the blank question. So answer 0.3333, or you may write 0.34 as well. No issue. Look at this question. We were given one vector and we were asked to decide whether this vector is solenoidal or irrotational, or both solenoidal and irrotational, or neither solenoidal nor irrotational. So first of all, let us calculate a divergence. Do you know how to calculate a divergence of a vector? So divergence of a vector is calculated as I coefficient derivative with respect to x partially, plus j coefficient derivative with respect to y partially, plus k coefficient derivative with respect to z partially, whatever you get, which is called its divergence. So I coefficient derivative with respect to x partially, when you are partially differentiating with respect to x, at that time x is only the variable. Other variables y and z shall be kept constants. So I coefficient derivative with respect to x partially minus 2. Plus j coefficient derivative with respect to y partially, y derivative 1 into 2x, plus k coefficient derivative with respect to z partially. So z derivative 1 into minus 2x, 1 into minus 2x, and one more term is there here 2z derivative with respect to z partially, that is 2. You observe divergence of given vector, they give small f bar, no, divergence of the vector equal to 0. So minus 2 plus 2 cancel, plus 2x minus 2x cancel. So the given vector is solenoidal. So let us verify whether it is irrotational or not. So for that you have to find curl f bar, means del cross f bar. How to write del cross f bar? Curl f bar equal to del cross f bar equal to determinant of 3 by 3 matrix, first row I bar, j bar, k bar, second row dou by dou x, dou by dou y, dou by dou z, I bar, j bar, k bar, second row dou by dou x, dou by dou y, dou by dou z, third row given vector ijk coefficients, y square minus z square plus 3yz, y square minus z square plus 3yz, and one more term is there, minus 2x, minus 2x. So j coefficient. So given vector j coefficient is 3xz plus 2xy, k coefficient. Given vector k coefficient 3xy minus 2xz, 3xy minus 2xz, 3xy minus 2xz plus 2z, plus 2z. So find the determinant of this matrix. Determinant of this matrix is del cross f bar equal to I bar into this I bar that is in this row, cut it, that is in this column, cut it, and find the determinant of remaining elements. Dou by dou y of 3xy, that is 3x. Dou by dou y of 2xz is 0, 2z is 0, minus dou by dou z of 3xz, that is 3x. Dou by dou z of 3xz, 3x, dou by dou z of 2xy, 0. So minus j bar into, so that is in this row, cut it, in this column, cut it, dou by dou x of 3xy, that is 3y, minus dou by dou x of 2xz, 2z, dou by dou x of 2z 0, minus dou by dou z of minus z square minus 2z, dou by dou z of 3yz, that is 3y, plus last term k bar, plus k bar into, delete that row, that column, dou by dou x of 3xz, that is 3z, dou by dou x of 2xy, 2y, minus dou by dou y of y square, that is 2y, dou by dou y of z square 0, dou by dou y of 3yz, 3z. So now you observe here plus 3x minus 3x plus 3y minus into plus minus 3y minus into minus 2z plus 2z minus 2z cancelled plus 3z minus into plus minus 3z plus 2y minus into 2y minus 2y cancel. So del cross f bar equal to 0. Del cross f bar value 0. So divergence of f bar 0, curl f bar 0. Therefore, the given vector is a solenoidal vector as well as irrotational vector. So correct answer, it is solenoidal but not irrotational. Wrong. Neither solenoidal nor irrotational. Wrong. It is solenoidal as well as irrotational vector. So options A and B are correct. Now you observe look at the question. F of z equal to e power z by z square, then z equal to 0 is a singular point. So first of all, write f of z equal to e to the power of z by z square. So denominator is equated to 0, we get z square equal to 0. So substitute z equal to 0 in the numerator, numerator not equal to 0. So e power 0, 1 not equal to 0, therefore z equal to 0 is a pole of order 2, is a pole of order 2. So singular point can be classified into, isolated singular point is classified into 3 types: removable singular point, pole, essential singular point. Pole means basically it is a singular point. So z equal to 0 is a singular point, correct? Z equal to 0 is a pole of order 2, correct? The residue of f of z at z equal to 0. Let me do that. The residue of f of z at z equal to 0, let us calculate. So this is e to the power of z by z square. Here 1 by z square common. E to the power of z. E power z expansion 1 plus z plus z square by 2 factorial plus z cube by 3 factorial plus 1. This is e to the power of z expansion. So from this, and this is equal to 1 by z square into 1 by z square plus 1 by z square into z by z square, that is 1 by z square cancel, 1 by 2 factorial, z cube by z square, that is z by 3 factorial plus 1. So 1 by z minus z naught coefficient is called residue of f of z at z equal to z naught. 1 by z coefficient is called residue of f of z at z equal to 0. So residue of f of z at z equal to 0 is 1 by z coefficient. What is 1 by z coefficient? 1. So residue of f of z at z equal to 0 is 1. So therefore option A is correct, options A, B, C are correct. So look at the question, what we were asked to find: if y double dash minus 5y dash plus 4y equal to 65 sin 2x, then which of the following statements are correct? So MSQ, so first of all, you have to write given differential equation y double dash minus 4y dash, sorry, minus 5y dash, no, minus 5y dash plus 4y equal to 0, equal to 65 sin 2x. So we can write y double dash at d square y by dx square minus 5 into y dash is dy by dx plus 4y equal to 65 sin 2x. Let us write the auxiliary equation. To get the auxiliary equation, dependent variable y coefficient is equated to 0. So y coefficient is d square by dx square means capital D square minus 5 into d by dx is capital D plus y coefficient is 4. So what are the roots? Minus 4d can be written as minus 4d, minus 5d can be written as minus 4d minus d. So accordingly, we can get the roots are 1, 4. So if two roots are real and distinct, what is the complementary function? C1 complementary function equal to C1 e power m1x e power 1x plus C2 e power m2x, that is e power 4x. So complementary function is C1 e power x plus C2 e power 4x. Complementary function is C1 e power, option A wrong, option B correct. C1 e power x plus C2 e power 4x. Complementary function correct. So we have to verify the particular integral as well. Particular integral. How do you write particular integral? 1 divided by dependent variable y coefficient. 1 by dependent variable y coefficient is d square by dx square means capital D square minus 5 into d by dx means capital D plus 4y. 1 by y coefficient into right side of the given differential equation into right side of the given differential equation. This is type 2 particular integral. To solve a type 2 particular integral, d square should be replaced by minus a square sin ax plus b. Sin ax plus b, a value 2. So d square is replaced by minus a square, minus symbol into a square, minus 1 into a square. So that is minus 4. So d square is replaced by minus 4. Substitute. Then it is equal to 1 by d square value minus 4 minus 5d plus 4 into 65 sin 2x. So here minus 4 plus 4 cancelled. So this is 1 by minus 5d, that is minus 1 by 5d into 65 sin 2x. So 5 ones, 5 13s. So minus 13 into, there are two choices. To solve type 2 particular integral, d square should be replaced by minus a square. So to make it as d square, multiply and divide by d. That is choice number 1. Choice number 2 is capital D means d by dx. 1 by capital D means 1 by d by dx means d by dx whole power minus 1 means inverse of d by dx means inverse of differentiation. Inverse of differentiation is integration. So you have to find integral sin 2x dx. Integral sin 2x dx. Sin 2x integration minus cos 2x by 2. Minus into this minus becomes plus cos 2x by 2. Cos 2x by 2. 2 already written here. So the particular integral is 13 by 2 cos 2x. Particular integral is 13 by 2 cos 2x. So accordingly option C also correct, and hence option D is also correct, because general solution is a complementary function plus particular integral. Complete general solution was given, hence option D correct. B, C, D are correct. So observe the question carefully. 2 marks question. for any two non-zero real numbers a and b. Remember, a and b are non-zero real numbers. Consider the following system of linear equations: ax plus by equal to b by 2, bx plus ay equal to a by 2. Which of the following statement is true? Which of the following statements are true? So first let me write the augmented matrix. Augmented matrix is denoted by AB. First equation xyz coefficients first row. First equation xyz coefficients first row. Second equation xyz coefficients second row. B A. So first equation right side b by 2. Second equation right side a by 2. First equation right side here b by 2. Second equation right side here a by 2. Now reduce this matrix to echelon form. So to reduce one matrix to echelon form, select the first row first element if it is some non-zero number. Using the selected number only, all below elements are to be made zeros using row operations only. So I can write a times of second row minus b times of first row. AR2 minus BR1. Then the augmented matrix is AB equal to first row A, B, here B by 2, A into R2 minus B into R1, A into B minus B into A, AB minus BA 0, AR2 minus BR1, A into A square minus B into R1, B into B, B square. Similarly, AR2 means A into A by 2, A square by 2, minus B into B by 2, B square by 2. A square by 2 minus B square by 2, that is A square minus B square by 2. So from here to, it has been reduced to the echelon form. So from here to here is matrix A and the last column is matrix B. Last column is matrix B, that's fine. Now suppose A equal to B. If I take A equal to B, then A equal to B square minus B square 0, A equal to B square minus B square 0. So then rank A value 1, rank KB value also 1 only. Similarly, if A equal to minus B, even I take A equal to minus B, then minus B whole square, B square minus B square, minus B whole square, B square minus B square 0. So then rank A equal to 1, because the last row of matrix A, in that case A equal to B or A equal to minus B, last row of matrix A and matrix AB are 0 rows only. Then rank A equal to rank AB. So if rank A equal to rank AB, system of equations will have either a unique solution or infinite solution. I mean system of equations are consistent. So for A equal to plus or minus B, system is consistent. So system will have either a unique solution. System is consistent means system will have either a unique solution or infinite solution. So that's why I can write system is consistent. Now we discuss A equal to B, it will have a solution. I mean system is consistent. What type of solution it is, like unique solution or infinite solution, we discuss right now. So if I take A equal to B, then what is the first equation? A equal to B, first equation, in place of B I will write A. Ax plus by equal to B by 2. A equal to B means I will substitute B equal to A. B equal to A, then it is Ax plus By, B equal to A, Ay equal to B by 2. B by 2, B equal to A means A by 2. So what is the common factor? A. So take out A, then it becomes x plus y equal to A by 2. They already said in the question that A is a non-zero real number, B is a non-zero real number. So for example, this is 3, this is 3, 3 cancel, because A and B are non-zero real numbers. So that's why, therefore x plus y equal to 1 by 2. How many values of x and y will satisfy this equation? Infinite number of x comma y values are satisfying this equation. This is 1 by 4, this is 1 by 4, 1 by 4 plus 1 by 4, 1 by 2. This is 1 by 2, this is minus 1 by 4. So 1 by 2 minus 1 by 4, that is 1 by, this is 1 by 2 minus 1 by 4, or this is 3 by 4, 0.5, 0.1, this is 0.1, this is 0.4, this is 0, this is 0.5. Infinite number of x comma y values will satisfy that equation. So if A equal to B, then system of equations has infinite solutions. So system has solutions, but how many solutions? Infinite solutions. Along x plus y equal to 1 by 2, system has a solution. That solution is infinite solution along x plus y equal to 1 by 2. Now we discuss A equal to minus B as well. If I take A equal to minus B, then if I take A equal to minus B here, A equal to minus B, so in place, or B equal to minus A, in place of B write minus A, because A equal to minus B. Ax minus Ay, A equal to minus B, B equal to minus A. So in place of B I will write minus A by 2. Ax minus Ay, then Ax minus Ay equal to minus A by 2. B by 2, B equal to minus A by 2. So A common, no? If I take A common, then it is x minus y equal to minus A by 2. A is a non-zero real number. So if A is a non-zero real number, A value 10, 10 cancel, non-zero real numbers. So from this I can write x minus y equal to minus 1 by 2. So multiply both sides by minus sign. Minus into minus y, that is plus y, y minus x equal to minus into minus 1 by 2. How many values of x and y will satisfy this equation? Infinite values of x and y will satisfy this. This is 0.6, this is 0.1, 0.6 minus 0.1, 0.5. This is 0.7, this is 0.2, 0.9, 0.4. So it will satisfy infinite values of x and y. So A equal to minus B also, it will have infinite solutions. Then system has infinite solutions. Along the straight line y minus x equal to 1 by 2. System will have a solution along y minus x equal to 1 by 2. That solution should be infinite number of solutions. Let us look at option A. If A equal to B, the solutions of the system lie on the line x plus y equal to 1 by 2. Option A correct. If A equal to B, system has a solution along x plus y equal to 1 by 2. If A equal to minus B, system has a solution along y minus x equal to 1 by 2. So along y minus x equal to 1 by 2. Option A correct, option B correct. We will discuss option C and option D same, A not equal to plus or minus B. So we have to discuss A not equal to plus or minus B case. If A not equal to B or not equal to minus B, A not equal to plus or minus B. If A not equal to plus or minus B, suppose A not equal to B, its value, this value 0 only when A equal to B. or only when a equal to minus b, then only this value 0. This value 0 only when a equal to b or a equal to minus b. Similarly, this is also. But in that case, we were given a naught equal to b and a naught equal to minus b. So that means it cannot be 0, it cannot be 0. So this 0, non-zero, non-zero. Therefore, matrix AB has how many non-zero rows? 2 non-zero rows. Matrix AB has 2 non-zero rows. Then matrix AB rank 2. Matrix A also has 2 non-zero rows. Matrix A rank also 2. And number of unknowns, how many? N means number of variables or number of unknowns. We have two variables. We have two variables x and y. Therefore, if rank A equal to rank AB equal to number of variables, then system has unique solution. System has a unique solution, a unique non-trivial solution. A unique non-trivial means non-zero solution. But your doubt is, sir, if I take A0, B0, what about this? It will be 0. And so rank A0, B0, if I take all 0 rows, then rank A0, rank AB 0. Then what to do in that case? Did you read the question? In the question they said A and B are non-zero real numbers, A and B. A and B are not zeros. So you cannot take A0, B0. So therefore, it is correct only A naught equal to plus or minus B, no solution wrong. If A naught equal to plus minus B, then the system has a unique solution, unique non-trivial solution. You observe, consider a sequence of independent Bernoulli trials with the probability of success in each trial is 1/5, then which of the following statement is true? Which of the following statements are true? That's fine. What is option A? Expected number of trials required to get first success. Expected number of trials required to get first success is E of x equal to 1/p. If an experiment is performed repeatedly until the occurrence of an event for the first time, then expected number of trials required for first time occurrence of an event is 1/p, where p is probability of occurrence of an event. So probability of occurrence of an event or probability of success is 1/5. So p value 1/5. So 1/1/5, that is 5. So hence option A is correct. Option A is correct. And option B, expected number of successes in first 50 trials is p. So they have already said these are Bernoulli trials. Bernoulli trials means it will satisfy binomial distribution. So therefore, expected number of trials required to get, expected number of successes in first 50 trials. Expected number of successes for first 50 trials, Bernoulli trials is NP. N means first 50 trials, so N value 50, P value 1/5, probability value 1/5. So 50/5, that is 10. 50/5, 10. So expected number of trials required for expected number of successes for first 50 trials is 10. Then option B correct. If option B correct, then option C wrong. Expected number of successes in binomial distribution meant for occurrence of an event. Expected number of successes in first 50 trials is 250. That's why it is wrong. Option D, probability of first success in fourth trial. What is option D? Probability of first success in fourth trial. So first success in fourth trial means first 3 trials are fail. Probability of success in each trial is 1 by 5. First trial fail, second trial fail, third trial also fail, because probability of first success on fourth trial. So first success happening on fourth trial. Prior to that first 3 trials are failure trials only. So therefore it is 1 by 5. So numerator 64, 4 cube 64, 25 into 25, that is 625, 625. So option D is correct, 64 by 625. Option D, 64 by 625. The probability of first success in fourth trial is 64 by 125. Look at the question. If f of xy equal to 3xy minus x square y minus x square, then which of the following statements are true? We'll discuss. First, let us write the given function. A given function f of x comma y equal to 3xy minus x square y minus xy square, minus x square y minus xy square. So find the values of p, q, r, s, t. So p means dou f by dou x, del f by del x. So x derivative with respect to x partially 1, 3y minus x square derivative 2x, 2x into y minus x derivative 1, 1 into y square. This is p, dou f by dou x. Also call it as del f by del x. Q. Q means dou f by dou y derivative 1, 1 into 3x minus y derivative 1, 1 into x square minus xy square derivative x into 2y, that is 2xy. So R means dou square f by dou x square. This is dou f by dou x. It's a derivative one more time with respect to x partially. So x derivative 1, 1 into minus 2y. That's it. Dou square f by dou x square. T means dou square f by dou y square. It's a derivative one more time with respect to y partially. Y derivative 1, 1 into minus 2x. Next S. S means f suffix xy. That is dou square f by dou x dou y. That is dou by dou x of dou f by dou y. Dou by dou x of dou f by dou y, that is dou f by dou y derivative with respect to x partially. Dou f by dou y derivative with respect to x partially. 3x derivative 3 minus x square derivative 2x minus 2y. 3 minus 2x minus 2y. So that's fine. To get the stationary point, solve equation P equal to 0 and equation Q equal to 0 in order to get the stationary points. So equation P equal to 0 and equation Q equal to 0. What is equation Q? So equation P, 3y minus 2xy minus y square, 3y minus 2xy minus y square, 3y minus 2xy minus y square. So here y common factor, please do take y common. So if I take y common, then it is 3 minus 2x minus y. 3 minus 2x minus y equal to 0. So either y equal to 0 and 3 minus 2x minus y equal to 0. Similarly, solve equation q equal to 0. What is equation q equal to 0? 3x minus x square minus 2xy. 3x minus x square minus 2xy. So x common factor, please do take out x as common. Then it becomes x into 3 minus x minus 2y. So either x equal to 0 or 3 minus x minus 2y equal to 0. So put y equal to 0. We should not substitute y equal to 0 in this equation. Same equation, we should not substitute y value 0. Y equal to 0 should be substituted there and x equal to 0 should be substituted here. From one equation, we cannot solve x and y values from one equation. So put y equal to 0 there. Here x equal to 0. If I take x equal to 0 here, for x equal to 0, then it is a 3 minus 2x minus y equal to 0. If I take x is 0, then it is a 3 minus y equal to 0. From this, y equal to 3. So what is the stationary point? X is 0, y 3. Accordingly, put y equal to 0 there. So if I take y equal to 0 here, for y equal to 0, if I substitute there, then it is 3 minus x equal to 0, 3 minus x equal to 0, accordingly x limit 3. So what are the stationary points combinations? Remember, same y value 0 should not be substituted from the same equation, and this x value should not be substituted in the same equation. This y value should be substituted there, that x value should be substituted here. That is the way to solve two equations. So one stationary point, here y0, x0, one stationary point. For y0, x value 3. So x3, y0, another stationary point. For x0, y value 3. x0, y value 3, this is another stationary point. Look at the question. In the question we have 0, 0, 0, 3, 3, 0, we got it. So 1, 1 is one of the stationary point. 1, 1 is one of the stationary point. Is it possible to find 1, 1 as one of the stationary point? Maybe possible. Let me check. So this equation I will take 3 minus 2x minus y equal to 0. 3 minus 2x minus y equal to 0. So from this, what is y value? Y equal to 3 minus 2x. Y equal to 3 minus 2x. Substitute this y value in the another equation. This 3 minus x minus 2y equal to 0. 3 minus x minus 2y equal to 0. So from this 3, this is the second equation, minus 2y, y value here 3 minus 2x equal to 0. So here 3 minus x minus 2 into 3 minus 6 minus 2 into minus 2x, that is 4x equal to 0. 4x minus x, that is 3x. 3 minus 6 minus 3 equal to 0. 3x minus 3 equal to 0. Divide both sides by 3. Then x minus 1 equal to 0. So from this, x equal to 1 is a stationary point. If I take x equal to 1 here, 3 minus 2 into 1, 3 minus 2, 1, 1 minus y equal to 0, so y equal to 1. So for x equal to 0, 1, we are getting y equal to 1 also. So therefore, the ultimately stationary points are stationary points are 0, 0, 1, 1, here 1, 1, already 0, 0 we got, x0, y0, x0, next x0, y3, y0, x3, 0, 3, 3, 0, 0, 3, 3, 0, 0, 3, 3, 0, 0, 3, 3, 0. Therefore, the stationary point 0, 0, 1, 1, 0, 3, 3, 0. It is MSQ, one or more options correct. So, option A correct. Now, we will discuss whether these 3 points are saddle points or not. We will discuss it first at 0, 0. At 0, 0, write RST values. What is R value? R value. At 0, 0, x0, y0, this is 0, t0. If I take x0, y0, this is 0, but it is 3. So, if I take x0, y0, r0, t0, s is 3. x0, y0, s is 3. r0, t0, s value 3. So, calculate RT minus s square. Calculate RT minus s square. So, RT minus s square 0 minus 3 square minus 9 less than 0. RT minus s square less than 0, 0, 0 is a saddle point. Saddle point. Next we will discuss at 0, 3. R value minus 2x. So, minus 2 into x coordinate 0, y coordinate 3. R value minus 2y. R value minus 2y, minus 2y, minus 2 into 3, minus 6. T value minus 2x. T value minus 2x, minus 2 into 0. S value at 0, 3 we will discuss. At 0, 3, x 0, 0, y value 3, minus 6, 3 minus 6, minus 3, minus 3. So, RT minus s square, R into t, minus 6 into 0, 0, minus s square, minus 3 whole square. So, that is minus 9 less than 0. So, RT minus s square less than 0. So, 0, 3 is saddle point. 0, 3 is saddle point, and we will discuss at 3, 0 as well. We will discuss at 3, 0. So, R value minus 2y, R value minus 2y, minus 2y, R value minus 2y, y value 0, t value minus 2x, minus 2 into x value 3, minus 2 into 3, minus 6, s value x3, y0, x3, y0, s value x3, y0, this is 0, x3, minus 2 into 3, minus 6, 3 minus 6, minus 3, 3 minus 6, minus 3. So, what is RT minus s square? RT minus s square 0 into minus 6, 0, minus s value minus 3. So, minus 3 whole square minus 9, RT minus s square value minus 9. So, therefore, 3, 0 is a saddle point, because RT minus s square less than 0 at any point, that point at any stationary point, that itself would be stationary point, saddle point I mean. So, 0, 0, 0, 3, 3, 0 are saddle points, that's fine. So, these are saddle points. If these are saddle points, then the function doesn't have either maxima or minima at the saddle point. So accordingly option D eliminated. Now we will discuss whether 1 is point of maxima or point of minima, that is to be discussed. Last stationary point 1, sorry, I will discuss at 1, R value minus 2y minus 2 into 1, T value minus 2x minus 2 into 1, R value minus 2y, y value 1 minus 2, T value minus 2x, x value 1 minus 2 into 1, S value, x value 1, y value 1, minus 2 into 1 minus 2, minus 2 into 1 minus 2, minus 2 minus 2 minus 4, 3 minus 4 minus 1. So S value minus 1, S value minus 1. So calculate RT minus S square, RT minus S square, minus 2 into minus 2 plus 4, minus S value minus 1 whole square, so 4 minus 1, that is 3, greater than 0. RT minus S square greater than 0 and R value minus 2 less than 0. If RT minus S square greater than 0 and R less than 0, then the function will have local maximum at that stationary point. So f of xy has local maximum at the stationary point 1, local maximum at the stationary point 1. 1 is a point of maxima, so accordingly options A, B, C are true. If z equal to x plus iy is a complex variable such that I square equal to minus 1, I mean I equal to root of minus 1, then and C is a circle mod z equal to 2 having center at origin and radius 2, which of the following statements are true? That's fine. So option A is true. How can you say that option A is true? E to the power of z is entire function, means analytic everywhere on the finite part of complex plane. So f of z is analytic everywhere, means on the entire complex plane, then the given function doesn't have any singular point inside the closed curve. So by Cauchy's integral theorem, the value of the integral is 0. Now option B, the residue of f of z equal to 4 by z minus 3 at z equal to 3 is 4. 1 by z minus z naught coefficient will be the residue. 1 by z minus z naught coefficient will be the residue at z naught. 1 by z minus 3 coefficient will be the residue at 3. So 1 by z minus z naught coefficient is the residue. 1 by z minus z naught coefficient is 4. So 4 is the residue. So option B correct. If option A correct, accordingly option B wrong. Integral e power z dz, it is 0 since it is analytic everywhere. Hence option C wrong. Option D, z equal to 2 is a pole of order 8. Z minus 2 equal to 0, z equal to 2 is a singular point. Substitute z equal to 2 singular point in the numerator. So it is a pole of order 8. So even if you want to write z minus 2 whole power 8 equal to 0, z equal to 2, substitute z equal to 2 in the numerator, numerator not equal to 0. Therefore, z equal to 2 is a pole of order 8. So you people have a doubt that, sir, why can't we solve numerator z minus 2 plus 2 by z minus 2 whole power 8. So if you solve like this, this is 1 by z minus 2 whole power 7 plus 2 by z minus 2 whole power 8. If you solve like this. So therefore z equal to 2 is a pole of order 8. So therefore pole of orders, that is pole of order 8.
Okay, here I am starting with the solutions of electric circuits, okay, of pre-gate solutions. Okay, I have included all the concepts and I have covered NAT, MSQ, MCQ, everything based on the correct standard and pattern. Yes, myself B.S. Krishna Verma, faculty in AC Engineering Academy in Days Online. Now look at the first question, sir. Very, very interesting. It's an NAT of 1 mark. numerical analysis type. The total energy stored in the circuit shown, okay, the total energy stored in the circuit shown after switch has been closed for a long time is. No doubt here the arrow indicates switch is getting closed, and switch has been closed for a long time. Switch has been closed for a long time means it is DC steady state. Yes or no? Because it is a DC excitation. So switch has been closed for a long time means it indicates DC steady state. So in DC steady state, energy stored. You know, sir, resistor never stores. Resistors converts and dissipates. But which are the components which can store? Pure inductor and pure capacitor will store. Of course, inductor will store energy in electromagnetic form. Capacitor will store energy in electrostatic form. Okay. So the total energy stored means we have to consider the energy storage components, both inductor and capacitor. But in which state? Because switch has been closed for a long time means DC steady state. Chalo. Now let us understand in DC steady state, you know, inductor acts like short, capacitor acts like open, and this capacitor acts like open, and this inductor acts like short. Chalo, if I write first the DC equivalent of this circuit, yes, this is 20 volts DC. Okay, this is 20 volts DC, and inductor is switch has closed, and you know inductor is shorted, capacitor is open. Okay, here also capacitor open, inductor short. Yes, here resistor is there, inductor is short, this capacitor is open. Okay, this is what it means for DC steady state. Okay, and of course this resistor is still 20 ohm. Okay, now you see, now the overall, now the effective resistance seen by this source is only the 20, you know. So 20 by 20, only 1 ampere. So this source will deliver 1 ampere. Now where this 1 ampere can go? Yes, 1 ampere will go here. Okay, this is open, again 1 ampere will grow here. So that means in these two inductors, the steady state current is 1 ampere. In these two inductors, the steady state current is DC 1 ampere. And of course, this capacitor voltage is 0. This capacitor voltage is 0 because voltage across short circuit is 0. Voltage across short circuit is 0. But this capacitor voltage exists, which is the voltage across resistor only, V equal to IR. This is 20 volts. Okay, now we got all the state variables of these memory elements. What are memory elements? Inductors and capacitors. They are the inertia elements. And what are the state variables? Inductor currents and capacitor voltages. This inductor current we got. This capacitor voltage does not exist because voltage across short circuit is 0. This voltage exists, which is the voltage across resistor. Now the total energy stored. So this cannot store energy. However, in steady state, we can use the formula for energy stored in inductor half Li square, and for energy stored in capacitor half CV square. So now the total stored energy is, one is this inductor half L. L is how much? 4 Henry, half L I square. I square is 1 square. Okay? Then this is 0. Then this capacitor will write half CV square. C is how much? C is how much? C 0.01. This energy is 0 because there is no voltage across it. But half CV square. C is how much? 0.01 farad. 0.01 farad. And V square. What is the voltage across this? V square 20 square. Plus again this inductor half Li square. L is how much? 2. That is half. L is 2. This I square is 1 square. Chalo, now if you observe, sir, this is clearly 2 plus this is 400 by 2, 200. 200 into 0.02 plus this is already 1. So 5 joules. It is how much now? 5 joules. Okay. So the total stored energy in the circuit is 5 joules. Because you know source supplies both energies. One in energy storage and also dissipated. But he asked only stored energy. Stored energy is in inductor and capacitor. Okay. Answer is how much? It is 5 joules. So it is an integer value of 5 joules, NAT type. Now let us go to any more interesting problem. See, look at this question. So for electrical, I introduced even 3-phase circuit. Okay. Yes, definitely you can expect 3-phase question. Obviously, no doubt, with all the fundamentals you got in machines, power system, measurements and power electronics. Yes, you can also write. And of course, in circuit, the bits are very simple. Now see this. Coils in the lines and phases of a 3-phase system are magnetically coupled. Okay. Coils are the windings, of course, inductors. In the lines and phases, these are lines in a 3-phase system, these are phases, you know, phases are magnetically coupled as shown. If the current in the line A, okay, if the current in the line A is 10 angle 0, determine the current in the phase connected between lines A and B. Determine the current in the phase connected between A and B. A and B are here, na? Okay, A and B are here. So this phase current is asking. He gave the line current in line A and is asking the phase current in this. Now, sir, first of all, let us observe. Is it balanced or unbalanced? Think carefully. The line inductors are 10 milli, 10 milli, 10 milli. and the phase inductance also 40 milli, 40 milli, 40 milli. And moreover, the mutual coupled, okay, mutual coupling between line inductance and phase inductance is also 20 milli, 20 milli and 20 milli. And you see the dots where they are. Like from line A, left side entering. From line B also, left side entering dot. From line C also, left side entering dot. So all are perfectly same. That means, though it is magnetically coupled, the line inductances, the phase inductances and the mutual inductance is also same. So this is a perfectly balanced three phase. If one of these change in answer, then it is a very tough problem. Then I would have used mesh and nodal. That is why in GATE and such exams, be careful in observing the data. Though suddenly it is a three-phase magnetically coupled system, but all line inductors are same, phase inductors are same. Moreover, the mutual inductance is also same with exact notation like entering left side entering, entering left side entering, entering left side entering, and these three mutual inductance same. So it is a perfectly balanced three-phase delta connected load, delta load. Yes or no? Yes, it is a perfectly balanced three-phase delta load. Though magnetic coupling is there, nothing to worry now. Now it is a balanced delta load, that's it. But he did not mention that, you see. So he never mentioned anything. So you have to observe that. So it is a perfectly balanced three-phase delta load, sir. Now simple. Now in a delta connected system, we know that in a delta connected system, I will take the option, but in a delta connected system, we know that line current, okay, lags, yes or no? Line current lags phase current by 30 degrees. And of course, line current magnitude is √3 times phase current. See, this is what we know in a balanced delta connected system. Of course, positive sequence. In a balanced delta positive sequence. Of course, default, sir. If he did not give, consider positive sequence only. Until unless he mentions it is a negative sequence, he will mention. Otherwise, it is a positive sequence, anti-clock. Now, in a balanced delta, line current lags phase current by 30 and line current is √3 times phase current. But here, ulta. He gave line current and he is asking phase current. Now let us write reverse. If you write reverse, what you will write reverse now? Phase current is line current by √3 and phase current will lead line current. So reverse of this, because he gave line data and he is asking phase. Because he gave line data as 10 angle 0. So now reverse, let us write. So from this I will write phase current, okay, because here line current lags, phase current leads line current by 30 degrees, be careful, and moreover phase current is line current by √3 in magnitude. Chalo. Now from this conclusion, since given line current is 10 angle 0 amperes, so what will be the phase current now? Let us write the answer now. The phase current will be line current by √3 and also it will lead. So line current by √3 in magnitude plus it will lead. So plus 30 degree in ampere. So phase current is 10 by √3 plus 30. That is the answer. 10 by √3 plus 30. If you observe, 10 by √3 plus 30, option C. 10 by √3 plus 30 is option C. Okay. Very good problem. Be careful. Okay. Though it is a magnetically coupled three-phase delta load, but balanced is that thing which is redefining everything very simple. Otherwise, calculations would have been very tedious. Okay. Now let us go to the next. Now this is another great problem. Of course, it is what you should identify. It is an MSQ. See the question. If ammeter A1 reads 20 amperes, okay, ammeter, it is an AC steady state where the supply current is 15 amperes. Without mentioning anything, it is considered as RMS values, okay, because without mentioning any polar quantity is considered as RMS, and moreover, ammeters and voltmeter reads the working value or RMS values only. They are designed to measure RMS values. So these are all RMS values. So ammeter A1 is reading 20 amperes, ammeter A2 is reading 9 amperes. This is reading 20, this is reading 9. Now we want the current through capacitor alone. Here the problem is in this case, he did not give individual currents. He did not give R separate, IL separate and IC separate. He gave combination. Ammeter A1 is reading the phasor sum of IR and IL. Ammeter A2 is reading phasor sum of IL and IC. But he want current through capacitor alone. That is a big challenge here. And we know an RLC circuit, whether it is series or parallel, an RLC circuit can behave in three ways. Yes or no? The RLC circuit can behave in three ways. Yes or no? Yes. It can behave in three possible ways. Okay, na? Like lagging power factor where IL is more in magnitude than IC. Leading power factor when IC is more in magnitude than IL, because load means current, sir. Lagging load more dominant means inductor current is more. Leading load more dominant means yes, capacitive current more. And it could be even unity power factor. But out of these three, if it was unity power factor, now listen carefully, if it was unity power factor, then phasor sum of IL, IC should be 0, because if it is unity power factor, these two should be phasor 0. So ammeter A2 should read 0, but ammeter A2 is reading here, ammeter A2 is reading. So out of these three cases in a parallel RLC circuit, parallel RL circuit, one of the case that XL equal to XC is ruled out, or IL equal, because if IL and IC are equal but opposite in phase, the phasor sum would have been 0, ammeter A2 should read 0, but ammeter A2 is reading here, ammeter A2 is reading. So definitely one of these cases is eliminated, but remaining two cases exist. What are the remaining two cases? Lagging power factor, leading power factor. So let us be careful now. So first, if I consider case 1 or case 1, lagging power factor load, okay, lagging power factor load. If it is lagging power factor node, no doubt inductor current is more than capacitor. So now for parallel, I will take voltage as reference. Okay, so let me take here voltage as reference. Okay, with respect to voltage, which current is in phase? IR. Okay, IL will lag, but it is more now. IL will lag, but it is more now. Okay, IL. What about IC? IC will lead, it is less in magnitude. IC will lead, of course, it is less. This is for lagging power factor load. Now from the data, now see ammeter A1. Ammeter A1 is a phasor sum of IR-IL. IR-IL phasor is how much? 20 amperes. IR-IL phasor is 20 amperes. So if you observe, IR-IL phasor sum is 20 amperes. Chalo, we got this. Then ammeter A2 is reading 9. But A2 reading is a phasor sum of IL-IC is 9. Phasor sum of IL and IC is 9. IL and IC. So this you subtract, because these two are unequal opposite forces. This much you subtract here. Okay, this is 9. This length is 9, which is phasor sum of IC and IL. This is phasor sum of IC and IL. Okay. Then altogether phasor sum of IR plus IL plus IC is 15. IR plus IL plus IC is 15. Okay. That if you see phasor sum of IC plus IL I got plus IR, this should be 15. This should be 15. This should be 15. Okay. So ammeter A1 is phasor sum of IR and IL is 20. Ammeter A2 is phasor sum of IL plus IC. IL plus IC is 9. This you subtract here, sir. 9. And altogether supply current is how much he gave? 15. 15 is a phasor sum of IR, IL and IC. Okay. That is already IL, IC we got here. Plus IR is 15. Okay. Chalo, we got everything here. Okay na? Now from this he is asking current through capacitor alone. Yes or no? Current through capacitor alone. Chalo, now see. Let us use this. Okay. Let us use the fundamentals now. See. From this triangle, if this is 15, this is 9. What is this length, everyone? Root of 15 square minus 9 square. 225 minus 81, root 144, 12. Now, if this is 12, this is 20. What is this total length then? What is this total length then? Root of 400 minus 1, root 256 means 16. If this is 16, this is 9. This has to be 7. If this has to be 7, so this length is IC length, na? This is also 7. So, 7 amperes is one of the possible answer. Yes, if you consider lagging power factor load, yes, 7 amperes is one possible answer. Okay, what about leading power factor? Now be careful, sir. In such exams, yes, all possible cases, because he did not give individual values here. Chalo, now case 2, let us go to case 2. Now if I go to case 2, leading power factor. Case 2, leading power factor. Chalo, if I go to leading power factor, here IL magnitude is less than IC. Leading means capacitor should dominate. Load means current. Moreover, load means current. Leading load means IC load should be greater. Now again, sir, let us draw the phasor diagram here again. Again, I will take voltage as reference. With respect to voltage, IR is in phase. Here IL lags, but it is small. IL lags, it is small. IL, okay, let me complete this. Sorry, let me correct this. Okay. Yeah, this is lagging, right? Okay, this is IL. What about IC? IC will lead, but here it should be more. IC should be more. Okay, this should be more. IC. So again, let us substitute the data. From the given data, phasor sum of IR, IL is how much? IR and IL is ammeter A, which is 20. Okay, IL plus IC is 9. This you subtract here. Okay, this much you subtract here, and this will be 9. 9. Then phasor sum of IR, IL, IC is together is supply, which is 15. IC plus IL we got plus IR, this is 50. Okay, chalo. Now from this he is again asking current through capacitor. That means This length you should find. This length you find, attached to this 9, then total length will come. Chalo, again, let us do the Pythagoras theorem now. Here again, sir, this is, see now, this is 15, this is 9. So this has to be 12. Root of 15 square minus 9. If this is 12, this is 20, right angle triangle, Pythagoras theorem, this has to be, how much now? 16. If this is 16, this length is also 16. Now, if this is 16 and 9, total will become 25 amperes. So IC is also 25. So there are two possible answers, sir. For lagging power factor load, yes, IL dominates IC, then current through capacitor is 7 amperes. For leading power factor load, where IC dominates IL in magnitude, then 25. So here both 7 and 25 are answers. So that is why you see it is an MSQ, both 7 amperes is also answer and 25 is also answer. Okay, 25 is also answer. So it is an MSQ, you have to check both. Of course, unity power factor still not there. Why? Because ammeter A2 is reading. If ammeter A2 wasn't reading, then that case will come. But luckily that is not the case, but both are possible. So for lagging power factor, 7 amperes is the current through capacitor. For leading power factor, 25 amperes is the current through capacitor. Because it did not mention both are. It is an MSQ, multiple selector. Okay, good question, sir. Okay. Now let us go to the next question. In the circuit shown, yes, R may be considered as infinite while the voltage VC is between 0 and 3. Okay, this is like open circuit infinite when voltage VC is strictly less than 3. But once VC touches 3, once VT touches 3, then R becomes 0. R becomes 0, instantly shorting the capacitor and discharging the capacitor. And immediately after again it becomes infinite again. So this is like a very interesting voltage controlled switch. The moment it, until this is less than 3, this is like open circuit. The moment it touches 3, it becomes short circuit and it will discharge the capacitor immediately and again becomes open again becomes open. Now the frequency of oscillation for the voltage signal VC is how much is asking. So very interesting now. So once it reaches 3, it's like short, discharge capacitor, and again it becomes open, and again charge, discharge, charge, discharge. So this is the concept and is asking the frequency of the oscillation. Now sir, though it looks like a normal problem, but here this is acting like a switch concept now, because once it reaches 3, this will discharge. So imagine like a switch concept. So switch concept means it is steady state or transient. This is transient problem. See the data, sir, because he said R becomes 0 instantly when the voltage reaches 0 is like a closed switch. This is becomes 0, like a short circuit across capacitor. So this is like a transient problem. So be careful with the data given. It is not steady state. Okay, chalo. So this is first of all transient problem, where I would say this is like a step response. Why it is like step response? This side, this is like a switch. The moment it reaches 3, it shorts, discharges. Again, open. Shorts, discharges when it is 3. So it is like a switch concept. So it is step response of first order RC circuit, and the state variable is what, sir? Voltage across capacitor. Yes or no? Now we know that this voltage across capacitor is like step response V of infinity plus V of 0 minus V of infinity into e power minus t by tau. Yes or no? Yes, this is what we know. Chalo, here what is V of 0? 0. Here V of 0 is clearly how much? 0, sir. V of 0, 0, because initially before this is given nothing. V of 0, 0. This came, yes, the moment. So for our solution, when this is acting, V of 0, 0. But what is V of infinity? Without considering resistor effect, it would have reached 6 volts. Yes, if this resistance effect is not there, it would have reached 6 volts, and that is deciding the slope. V of infinity is 6 volts. I know it won't reach there, because the moment it reaches 3, it will. But without considering first the change, let us consider the initial value and final value, but it may not reach there because that resistor will discharge. And what is tau? Tau is R equivalent into C equivalent. What is R equivalent? R equivalent is 10 kilo, and C is how much? 0.1 microfarad. So this is like 1 millisecond. Yes or no? Now if you take the expression, this Vc of t is V of infinity into 1 minus e power minus t by tau minus 1000 t volts. Chalo, we got the expression for all t greater than or equal to 0. For all t greater than or equal to 0. But he said that once this reaches 3 volts, now that is very interesting. Once this reaches 3 volts, what happens, sir? The capacitor will discharge because that resistor acts like short circuit. So idea is, once this reaches, capacitor will discharge immediately, and that time is the time period of the pulse which decides the frequency. So now the reason is the moment this reaches 0, at what time you have to find, and once you get the time period, frequency is 1 by time period. So if you go with that, yes, when VC is equal to 3 volts, R becomes 0 where capacitor discharges. Capacitor discharges. Yes or no? Quickly, instantly. And there is no time constant while discharging because it becomes 0. If this was there with some value, then discharging time constant also would have happened. But there is no time constant here. Discharges. Okay. Chalo, in that regard. So when this is 3, in this equation, when this is 3, this is 6 into 1 minus e power minus 1000. And this t is the time period. Time period of the pulse. Okay. Chalo, from this, if you see, this 1 minus e power minus 1000 t was equal to, this is half. You bring this side, e power minus 1000 t is again half. Now if you take natural logarithm, okay, yes, minus 1000 t is natural logarithm of half. It is 0.693, minus 0.693. So this is t is minus 0.693. So time period is 0.693 by 1000. So frequency is, now frequency of this pulse is 1 by time period. 1 by time period is 1000 by 0.693. You will get this as 1.44 kilohertz. 1.44, because 1 by 0.693 is 1.44 kilohertz. You will get. That means it is a concept where it starts 0, it would have reached 6 volts. It will never reach. Okay, as this is going, what is happening? As this is going, and once it reaches 3, okay, it discharges. 3 discharges, 3 it discharges, 3 it discharges. Now this is the time period what we calculated, and 1 by time period is frequency. Okay, beautiful concept. Okay, but understand, sir, it is a switch concept where this is there. So answer is 1.44 kilohertz. It is an NAT 2 marks type numerical analysis. Okay. That is how your electronic circuits will work, sir. Okay. But here I told in terms of that register, actually it could be a high frequency switch. It could be a high frequency switch. Okay. Or MOSFET switch or something like that. But that is a concept of generating waveforms. Okay. Now look at the next model, everyone. I want everyone to look at the next model here. Determine the voltage Vx in the figure below if Z1, Z2, Z3 is 2 minus J2. Z1, Z2, Z3 is 2 minus J2. And however, yes, ZA, ZB and ZC is 4 plus J4. Okay, 4 plus J4. So, yes, this is what I want to say. Yes, very, very interesting problems are here. Everyone, look at this problem. Now, determine the voltage Vx in the circuit shown. Now, see, if you go with a normal way of converting star delta, delta star, nodal mesh, it is a very lengthy problem. It is a really lengthy problem, sir, let me tell you. But you see this. Now, what I will do, see, I will take the advantage of symmetry because he told that Z1, Z2, Z3 are, of course, yes, this is 2 plus J2 and this is 4 plus J4. Okay, Z1, Z2, Z3 are how much he told? 2 plus J2. And ZA, ZB, ZC are how much? 4 plus J4. Okay. Now, because they are equal, you can take the advantage of symmetry. How? Let us see this now. Now, first let us try to make it symmetrical. Now, what I will do, let me take this Z1, Z2, Z3 as, okay, Z1, Z2, Z3 as some Z, okay, Z1, Z2, Z3 as Z. And this Z is how much he gave? That is 2 plus J2. 2 plus J2. And let this be ZA, ZB, ZC as some Z dash, which is 4 plus J4. Okay, now I will write this circuit very interestingly this way. Everyone watch this, please. The same circuit I am writing like this. So, let this be the same way. It is how you analyze, sir. That interesting conclusion you get into, then everything is simple. I will tell you why I am writing like this, because that is the fastest way to do. Now, this is the supply, sir. Let us not disturb this. Okay. This is Z1, but I already took Z1 as this is Z only. This is also Z. This is Z. And this ZA, ZB, ZC, I think Z dash. This is Z dash, Z dash. This is Z dash by 2 and Z dash by 2. That is a trick in writing here. So this ZC, I assumed as Z dash, but I am writing like 2 equal halves. But they are in series, like Z dash by 2, Z dash by 2 in series is Z dash. But you see, we are reducing with respect to source and I want this voltage. So here you cannot do even star delta because this is the branch voltage. You do star delta, you are disturbing the branch. That also not possible. And doing mesh and nodal is a lengthy process. So what I will do, I will take the advantage of symmetry. Now with respect to my source, where it is connected, let this be A, B. If you observe, now this is mirror image or not? Yes, mirror image symmetry, sir. You see now this side and this side are mirror images. With respect to common axis where my source is connected, this side and this side are mirror images. Because ZZ, this is mirror image. Now in mirror image, if you can identify such nodes which are at equidistance, we can join them. Because the nodes which are equidistant from the common axis are the nodes which are at same potential, you can join them. So if you observe, these two are at same potential. Let this be X and Y. So I will join them. That is a shortcut. Chalo, now what I will do with respect to my branch. Now everybody watch this please. Okay, with respect to my branch where Z and Vs is there. Yes, this is Z and this is Vs. Okay. Yes. Now I am joining this. This ZZ parallel become how much? Z by 2. Because yes, I am joining Z by 2. Z by 2. And this Z dash parallel also becomes Z dash by 2. This become Z dash by 2. Okay. And however, this is waste, sir. By joining, this becomes a self loop. This again becomes total Z dash by 2. Z dash by 2 is unnecessary Z only. Okay. This becomes X plus 5 we joined here now. Yes, if you observe, we joined here X plus 5. Okay. We joined here by X plus 5. Because we joined that X plus Y node. Okay. This total is again Z, which is a redundant element. Okay, so this Z dash by 2 is Z dash is a redundant element because by joining it becomes a self loop and there is no potential difference for current flow. That is why I eliminated that. So now no need to worry. Now you can remove that, okay, because there is a self loop where there is no potential difference, current cannot flow. But I want which voltage now? I want this voltage across this. Yes, this is Vx you want. Okay. Now sir, if you substitute the values, okay, now you know what is Z value he gave. Z value is 2 plus J2. Of course, this is 2 plus J2 ohms. Okay, this is half of this. This will become 1 plus J1 ohm. And this is Z dash by 2. Z dash by 2 is 4 plus J4 by 2 is 2 plus J2. So now in this regard, if I do voltage division rule, this voltage is total voltage into, total voltage how much? 100. Total voltage into same by sum. Same by sum. Same is how much? 1 plus J1 by sum. If you take sum 2 and real part is also 5, imaginary part is also 5. So here you take this 1 plus J1, cancel that 1 plus J1, denominator is 5, 100 by 5, yes, that is 20 at an angle 0 volts. 20 at an angle 0 volts. Very simple, na? 1 by 5, 20 at an angle 0. Okay. So there are many ways to do, but see how simple you can do it in 2 minutes is a challenge, sir. And that is very, very important. Okay. So answer is 20 at an angle 0, that is option B. Now let us go to the one more problem. Here you see, now this is a direct problem. Maximum power absorbed by the load is dash. Maximum power absorbed. So this is clearly maximum power transfer theorem is also maximum power absorbed. But this is Thevenin's category 1, 2, 3. Independent, dependent other. Thevenin's category 3. Okay, you can do VOC by SC. Yes. Chalo, first step I will do VOC. Step 1 I will do VOC. Now sir, same problem, that is nothing but VTH, of course. Now same problem, what I will do? This is my VOC or VTH. Let me find that first. Okay, let me find that first now. See, this is Ix he gave and there is a current dependent voltage source. This is 5Ix. Of course, this is 5Ix. And this is 50 volts given. Chalo, 50 volts given. And this is still 10 ohms, 5 ohms, and this is 20 ohms. My challenge is to find this Thevenin's voltage or open circuit voltage. Yes or no? So this voltage I want. Now sir, easy way you think, sir, don't go in a conventional way. Now if I write the big KVL first, I will get the value of Ix because minus 50 plus 20 Ix plus 5 Ix is 0. Yes or no? Minus 50, 20 Ix plus 5 Ix. So 25 Ix is 50, Ix is 2. Ix is 2. Now the moment Ix is 2, this become 22s of 40 volt. Now if I do voltage division rule, this voltage is total voltage 40 into same by sum. Same is 10, sum is 15. So now I will write another KVL to get VOC. If you write a KVL to get VOC, another KVL minus 50, okay, plus this voltage, okay. This voltage is how much? 40 into 10 by 15. 40 into 10 by 15, okay, plus VOC is 0. Plus VOC is 0. Okay. Here 5 3s are, okay, 5 8s are, okay na? So VOC is 50 minus 50 minus 80 by 3. So VOC is 150 minus 80, 70 by 3 volts. That is VOC. Now step 2 is to find RTH. Now step 2 is to find resistance. Now you can directly deactivate and apply Ohm's law. So what I will do, yes, see, to get RTH or RL, what I will do, first I will deactivate, but dependent source you cannot. So remove that. So what I will do is, yes, I will deactivate this independent source and I will apply Ohm's law by taking some test voltage, let us say V test voltage, and this is still dependent source and this is still the branch where dependent. This is 20 ohms and of course IX. This is 10 ohms and this is 5 ohms, right? 10 ohms and 5 ohms, and this is 5IX. 5IX. Now here also, sir, let me be very simple. Now if I write the first big KVL, 20IX plus 5IX is 0. That implies IX is 0. Now the moment IX becomes 0, this dependent voltage source becomes 0. The moment Ix becomes 0, dependent voltage source becomes 0. Dependent voltage source becoming 0 can be replaced by short circuit. So what happens now? You see this, very interesting. So that is an easy way, sir. Then because this dependent voltage source is 0, I short it. This is also shorted. Now this is still 10 ohms and this is still 5 ohms. This is my test voltage V total where I am applying Ohm's law. Now this V total by current itself is resistance, but this resistor is now shorted. See this resistance, because this is shorted as Ix is 0, this resistance, because it is between same two nodes, it is like shorted. This resistance is also shorted, that becomes redundant. So directly if you see this RTH is, yes, that is voltage by current, that is nothing but 10 in parallel to 5. Okay, that is 50 by 15, which is 10 by 3 ohms. The easy way, sir, the easy way. Because this resistance also is now shorted. This resistance is also shorted, it won't come. So the resistance seen by this is these two in parallel. So now Pmax is, yes, this VTH square by 4R. You take VTH square, yes, you take VTH square, this is nothing but 70 by 3, okay, 70 by 3 into 70 by 3 by 4 into RTH. RTH is again 10 by 3. You do that, okay, you do that, finally you will get it as, yes, 246 by 6 watts you will get. You check it, you will get this as 246 by 6 watts, which is option D. Okay, 246 by 6 option D. Okay, so here I gave a balanced paper. Yes, on circuit theory, where all solutions accurately I give. Okay, all the best.
Okay, pre-GATE 2026 electromagnetic fields. Here is a question, 1 mark question on the charge distribution, volume charge distribution. Let the volume charge density rho v is equal to 40 xyz microcoulomb per meter cube. The total charge within the region defined by x comma y comma z ranging from 0 to 2 is dash microcoulombs. Fine. So, if the volume charge is given, how do you find out the total charge? The Q is equal to volume integral of rho v into dv. Clear? So, this is equal to volume integral of 40 x y z dx dy dz. So, bring the constant outside and separate out the variables. So, it is x into dx, y into dy, z into dz. Perform the integration here. So, it is a 40 x square by 2. X limits are from 0 to 2. This is y square by 2, y limits are from 0 to 2 into z square by 2, z limits are also from 0 to 2. Upper limit minus lower limit. So, here 40 divided by 8 into 2 square into 2 square into 2 square. So, check out this value. So, this one is 320 microcoulombs. So, it is a numerical answer type question. 320 is the answer. Fine. Let us have next question, 2 marks question. Yes. So, this is question on the magnetic field. And infinite surface current K is equal to 100 Z cap ampere per meter placed on y is equal to 4 meters plane. the magnetic field intensity at the origin is. So at 10 comma 10 comma 10 is, at 10 comma minus 10 comma minus 10 is, at 5 comma 4 comma 2 is. So it is a MSQ question. Okay. So let me draw some rough diagram here so that we'll get an understanding how we can place this infinite sheet current here. So this is x-axis, this is y-axis, this one is z-axis. The infinite sheet is located at y is equal to 4 meters. So here this is how the infinite sheet current is located at y is equal to 4 meters. Fine. So, and that too the current is flowing in a z direction. So, this is the direction of the current flow. So, if I put my thumb like this, my fingers will going to show the direction of the magnetic field. So, here if I put my thumb like this, my fingers will going to show the direction. This is the direction of the magnetic field up, this is the direction of the magnetic field down. And this is a normal direction, it is a plus y cap, this is a minus y cap. Okay. So, and what is the formula? H is equal to k by 2 cross plus or minus n cap. This is a formula for the infinite uniform sheet current. So, what is this k here? The k here is 10 z cap by 2 cross plus or minus y cap. I will going to turn the page here. So, H is equal to 5 into z cap cross plus or minus y cap. Okay. So, this is how we can perform the cross product x cap, y cap and then z cap. So, it is asking at the 4 different points. What is the first option? At the origin is, at origin 0 comma 0 comma 0. So, what is this origin? This point is below the sheet. The sheet is at y is equal to 4 meters, the origin is below. If I am below the sheet, the normal direction is in the negative y direction. So, it is in the negative y. So, it is so z cross y is a positive x, one more minus is there, it will become z cross y is negative x, already minus is there, it will become plus. But what is said? Yes, he said plus. So, this is correct. Option A is correct. Next, at 10 comma 10 comma 10. At 10 comma 10 comma 10. Where is this 10 comma 10 comma 10? The infinite sheet is located at y is equal to 4 meters. 10 comma 10 comma 10 is above the sheet. If it is above the sheet, the normal direction is in the positive y direction. So, it is a positive y. H is equal to 5 z cap cross positive y. So, H is equal to, it is a y cross z is y, z cross y is negative x. So, it is a 5 x cap, it is a negative. Yes. So, negative. Check out, is that true? Negative 5 cap. Yes, this is correct. Next, 10 comma minus 10 comma 10. So, one more point is at 10 comma minus 10 comma minus 10. So, it is the minus 10. So, the minus 10 is below the sheet. Below the sheet is normal direction is in the negative y direction. It is a y z cap. It is in the negative y. So, the negative y in the sense, so z cross y is negative x, already one more is there, it is a positive. So, it is a 5x cap. Yes, 5x cap, this is correct. Next, at 5 comma 4 comma 2. So, where is that point? At 5 comma 4 comma 2. Five comma 4 comma 2. 4 comma 2 in the sense you are on the sheet, isn't it? If we are on the sheet magnetic field is not defined. On the charge electric field is not defined. On the current carrying conductor magnetic field is not defined. Just after that the magnetic field exists. So, it is not defined. What it is? Not defined. Yes. So, what is the answer here? This is not the answer. It is not defined. On the charge, on the current carrying conductor, fields are not defined. Anyhow, Yes, one more question. This is on the a composite capacitor. A coaxial capacitor has a dimensions A is equal to 3 centimeters and B is equal to 12 not centimeters, 3 mm and B is equal to 12 mm. That means inner surface radius, outer surface radius, and the length of 1 meter. The region between the conducting cylinders contains the three dielectrics epsilon R1 is equal to 5 and whose range is from 3 mm to 6 mm. Epsilon R is equal to 3 and then whose region is from 6 mm to 9 mm. Epsilon R1 is equal to 1 whose region is from 9 mm to 12 mm. The capacitance in the picofarads is. Let me draw some rough diagram here. So there are three regions are there. This is the first region, this is the second region, this is the third region. Clear guys? So what is the first region here? This is having a radius, this is 3 mm. This one is 3 to 6 mm. From here to here it is 9 mm. From here to here it is 12 mm. Outer one is a 12 mm. So here between these two things epsilon R1 is equal to 5. Between these two things epsilon R2 is equal to 3. Between these two things epsilon R3 is equal to 1. Okay, fine. Now see here the voltage connected is same. So the voltage is connected between this inner cylinder to the outer cylinder. Yes. So that means these can be treated as a series connection. So if I make a connection here, so there is some voltage will going to split between these two things, these two things, these two things. So this is a series connection. Okay. So what is the capacitance formula? C is equal to 2 pi epsilon L divided by natural log of B by A. I will going to turn the page here. Let us find out the C1. C1 is equal to, let me go back here. Yes. So here we are going to find out here C1, C2, C3. What is this C1 here? The C1 is 2 pi epsilon. What is this epsilon value? 8.854 into 10 to the power of minus 12 into epsilon R1. What is the epsilon R1? Epsilon R1, how much is the epsilon R1 is 5 into length is 1 divided by natural log of B by A. What is the B by A guys? The B by A, it is a 6 mm by 3 mm, that means 6 by 3. So check out this value. My calculator is showing its value as 400.91 picofarads. Next C2, 2 pi into 8.854 into 10 to the power of minus 12 into, what is the dielectric constant? Epsilon R2 is 3. 3 into 1 divided by natural log of 9 by 6. So check out this value. This is showing my calculator as 411.22 picofarads. Next C3 guys. 21 into 8.854 into 10 to the power of minus 12 into, what is this epsilon R3 is a 1 and 1 divided by natural log of 12 by 9. So which is equal to 193.19 picofarads. So, as I said earlier, this is in the series connection, isn't it? So, if they are in a series connection, so equivalent capacitance is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Yes, so this is equal to C total is equal to 1 divided by 1 by C1. What is the 1 by C1? It is 400.91 into 10 to the power of minus 12 plus 1 by C2. That is 411.22 into 10 to the power of minus 12 plus 1 by C3, which is 193.19 into 10 to the power of minus 12. So, check out this value. My calculator is showing its value as 98.99 picofarads. Yes, guys. So, 98.99 in the answer in the question is asking in terms of the picofarad. 98.99 is the answer.
Hello students. So in this I'm going to solve the questions which are from signals and systems. So this is from our pre-GATE 2026 exam. Let's look at the first question. A causal LTI system is described with a transfer function h of s. The input is u of t. What's the steady state value of the output y of t? So they're asking the steady state. So let's find the final value here. So what is expression for y of s? Expression for y of s is x of s into h of s. X of s. So x of t is u of t, its Laplace is 1 by s into, if you look at h of s, which is s minus 1 divided by s plus 2 into s plus 3. So when I look at y of s, there are three poles, one at origin, other at minus 2, other at minus 3. So there are there's a simple pole at origin and other two are in the left half of S plane. So there is no problem, you can apply final value theorem. So let me write what is final value theorem here. According to final value theorem, so the signal value or the output value as t tends to infinity, it is given by this formula, which is limit s tends to 0, it is s into y of s. So let's use that formula here. So y of infinity is limit s tends to 0, s into y of s is 1 by s into s minus 1 by s plus 2 into s plus 3. So you can see this and this cancels. As s tends to 0, the numerator is minus 1, the denominator is 2 into 3, and then the final answer is minus 1 by 6. So do we have such options? Yes. So in the steady state, your output value would be minus 1 by 6. Here they gave x of n as 1 by 3 whole power n u of n convolved with 1 by 2 whole power n u of n. They want the Z transform value at Z equal to 1. So you can see that this is a convolution operation. Convolution in time leads to multiplication in frequency. So if you want the x of z, so write like this: 1 by 3 whole power n u of n convolved with 1 by 2 whole power n u of n. So what happens to its z transform? You have to multiply the individual z transforms, that is z by z minus 1 by 3 into z by z minus 1 by 2. So what is this? This is x of z. Now I want this expression at z equal to 1. So x of 1, which is 1 by 1 minus 1 by 3 is a 2 by 3 into 1 by 1 minus 1 by 2 is 1 by 2. This and this cancels, and this overall answer will be 3. So the answer to this problem is 3. The z transform value at z equal to 1 is 3. So they gave x1 and x2. They are saying they are convolved, and you got y of t, which is x1 of t convolved with x2 of t. The energy of y of t is, so how do you find energy? So since there is a convolution in time, it leads to again multiplication in frequency. But in addition to that, we also need the energy. So first let me write like this. So what is y of t? Y of t is x1 of t convolved with x2 of t. So if you apply Fourier transform, then y of omega is x1 of omega into x2 of omega. Now once you know y of omega, it's easy to find the energy of y of t using the Parseval's theorem. So let's see what is y of omega. You need to find the Fourier transform of this. You need to find Fourier transform of this and then multiply it. So let's look at what's the Fourier transform of e power minus t into u of t. It is 1 by 1 plus j omega. What's the Fourier transform of sine pi t by pi t? It is a rectangle from minus pi to pi with a height 1. So this is which domain? Omega domain. So this is like x2 of omega. This is like x1 of omega. We need to multiply. So you know how does y of omega look? Y of omega, because it's a product. So the product you will write, or you'll have a non-zero value for the product from minus pi to pi, because outside this Fourier transform is 0. So when I multiply this with this, the answer would be 1 by 1 plus j omega from minus pi to pi, and outside this it is 0. Now you know the Fourier transform, it's easy to find the energy. Let's go to the next page. How do you find the energy? So the energy of a signal is given as, it is 1 by 2 pi integral omega from minus infinity to infinity. It is y of omega modulus square d omega. So we have seen just now that y of omega is only from minus pi to pi. So quickly change those limits. So this will be like 1 by 2 pi integral minus pi to pi. In this interval, you need to take its magnitude and then square. The magnitude of this fellow is 1 by root of 1 square plus omega square, and then you have a whole square. So this leaves you the answer as 1 by 1 plus omega square, then d omega. This is an even function. You can write twice 0 to pi. So this will be like 2 by 2 pi integration 0 to pi 1 by 1 plus omega square d omega. Complete this integration, substitute the limits. You need to use virtual calculator here. So try to use that. This will be 1 by pi tan inverse omega, and the limits are 0 to pi. So when I substitute the limits, it will be tan inverse pi, and tan inverse 0 is anyway 0. So you need to use virtual calculator. Let's see, I can open a virtual calculator here. So using the virtual calculator, you need to find that value and make sure it is in radians. So what tan inverse pi? So let me first take pi, and then before that let me put the calculator in radians. So this is pi and then tan inverse of that, and then this divided by pi. How much is this? 0.401. So when I use a calculator, it is giving me 0.401, and he says round off to how many decimals? 2 decimals. So when you round off to 2 decimals, it is 0.40. So this is the answer to this question. A continuous time periodic signal x of t is defined over a period 0 to 2. So the time period is given as 2 seconds. So in one time period from 0 to 1 it is t, from 1 to 2 it is 2 minus t. This signal is passed through an ideal differentiator. The resulting output signal is y of t. If the trigonometric Fourier series representation of y of t is given by summation 1 to infinity bn sin n omega naught t, then the value of summation n from 1 to infinity bn square is. So how do you find the value of this summation? So before you find the value of that summation, try to imagine a system which is given to you like this. It says it is passed through an ideal differentiator. So what does the ideal differentiator do? If you apply x of t as the input, what does it give you? It differentiates the input and produces the new output. So how are the input output related? Your output is simply the derivative of input. So this is how the input output are related. X of t is given. You can also get an expression for y of t, just differentiate it. So what is y of t? If I differentiate, the derivative of t is 1. So this is in the interval 0 less than or equal to t less than 1, and 2 minus t derivative is minus 1, and this is in the interval 1 less than or equal to t less than 2. When you try to draw this periodic signal, I feel like it's an odd signal, and this also confirms that, if you look at the Fourier series expression of y of t, there is no a naught. If you observe Fourier series expression for y of t, there is no an. So all the terms are in sign, which indicates that y of t is an odd signal. So what are your observations? Let's go to the next page. If you look at the Fourier series which is given, from that we can understand a naught is 0, an is 0 for all the values of n. For all the values of n. Now finally we need to find the summation. Let's recall what is Parseval's theorem. So what Parseval's theorem says is it is going to link the average power with the trigonometric Fourier series coefficients. How does it link? The average power is given by this expression integration 1 by t integral over t. It is y of t modulus whole square dt. So this is how you find the average power in the time domain. And how do you find it in the frequency domain? Or using your Fourier series coefficients, it is a naught square plus 1 by 2 summation n from 1 to infinity, it is an square plus bn square. So this will definitely give you the answer. Right now a naught is 0, an is 0 for all the values of n. Then what remains is, I'll rewrite like this, 1 by 2 summation n from 1 to infinity bn square will be equal to 1 by t. So in the present question 1 by t, or t capital T is 2, so it is 1 by 2 integration 0 to 2 and then y of t modulus whole square dt. In the question he doesn't want 1 by 2 summation bn square, he wants only the summation 1 to infinity bn square. So summation n from 1 to infinity bn square, I can send this 2 to the other side, and then this will be like 2 by 2 which cancels, and then I want to split the integration 0 to 1. The value of y of t is 1, so 1 square is anyway 1, plus 1 to 2 y of t value is minus 1 whole square is anyway 1, and then dt. So if you can simplify this, that gives you the answer. First of all, this and this cancels. If you integrate this, you get 1. If you integrate and substitute the limits, you get 1. 1 plus 1 is 2. So finally summation n from 1 to infinity bn square. So this is 1, this is 1, 1 plus 1 is 2. So 2 is the answer for this summation. Let x of n be a periodic signal with n equal to capital 6 and discrete Fourier series coefficients capital X of k equal to 3, 2, 1, 0, 1, 2 for k equal to 0, 1, 2 up to 5. He defines a new sequence y of n which is x of n minus x of n minus 3. The average power of y of n over one period is. So finally what you need to find? The average power of y of n. How do you find the average power here? The average power is calculated like this. The average power is 1 by n summation n from 0 to n minus 1. It is y of n modulus square. If you have y of n, you can directly substitute, but here I don't have y of n. Maybe I can find its discrete time Fourier series coefficients. There's a Parseval's theorem which says that this average power is also calculated like this. Summation k from 0 to n minus 1, and then it is, let's say the coefficients are represented with y of k here, and then y of k modulus whole square. If you can find this summation, you will get the answer. To find the summation, we need y of k. How do you find this y of k? So first, in the question, they say the value of n is 6. And then they give a relation. What is that relation? that y of n is x of n minus x of n minus 3. I want y of k, that is your discrete time Fourier series coefficients. So how do you find y of k? So y of k is calculated like this. Here the coefficient would be x of k, and here you need to use the shifting property. So because of the shifting property, it will be like e power minus j 2 pi 3 into k, 3 into k whole divided by n, that is 6, into x of k. So what is common is x of k. What is left is 1 minus e power minus j, 2 into 3 is 6 cancels, it is pi k. So e power minus j pi k. So what happens for this e power minus j pi k is, whenever k takes values like 0, 2, 4, the value of this will be 1. Whenever k takes odd numbers like 1, 3, 5, this e power minus j pi k value would be minus 1. Now when this becomes 1, 1 minus 1 is 0. When this becomes minus 1, 1 minus of minus 1 will be 2. So how do you write y of k? Y of k has to be written like this for k values 0, 2, 4 and for k values 1, 3, 5. So here when I put 0 or 2 or 4, this becomes 1, 1 minus 1 is 0, and then x of k into 0 is anyway 0. And when I put values like 1, 3, 5, this becomes minus 1, 1 minus of minus 1 is 2, so this becomes 2 into x of k. So now you know what is y of k, and then you need this sum, or you need the average power. Let's expand this. For values like 0 to 4, y of k would be 0, so it will be like fine, and then there is also a 2 here, so it will be 0 square plus, when I put k as 1, so it is 2 into x of 1, so 2 into x of 1, 2 into 2, so and there is also a square. Maybe I'll write like this. Anyway, this 2 gets squared, so which is 4 into, I'll write y of k here, or better, it will be good for our understanding. Y of k will be 2 times 0, 2, 1, 0, 1, 0. So this will be y of k, where 2 is also multiplied. Since 2 is multiplied, 2 square is 4, I wrote that out. 0 square is anyway 0, and then you have 2 square, and then I think I made a mistake here. Let me write this properly. So 0, 2, 0, and again the signal value is 0, 0, and then 2. So 4 times, this is 2 square plus 2 square, 4 plus 4 is 8, 8 4s are 32, so the value is 32 now. So the average power is 32. Like you might ask, like how did I write this? See here, for k 0 to 4, so here k is 0, 2, and then 4, so for these values it is anyway 0, and for k 1, 3, 5, so here it is 1, 3, and then 5, it is 2 times x of k, so I have multiplied it with 2. So that's how you get this. It is very simple. Let's go to the next one. It says consider the discrete time system y of n equal to x of n into summation k from minus infinity to n del of k minus 2. And then he's asking about the system is. In the options, we need to decide the linearity principle and the time invariance nature. So first thing is observe this. Before this, let me write one more standard result. Minus infinity to t del of tau d tau. Everyone knows this. What is this? This is u of t. So just like the integration, now look at this. K from minus infinity to n del of k. What is this? This is your unit step sequence u of n. When you observe this summation, which is giving you u of n, and when you observe this, you will get a thought. You will get an idea that this summation is also in terms of the step sequence. So now summation k from minus infinity to n, it is written as del of k minus 2. This will be equal to what? U of n minus 2. If this you have accepted as u of n, then this will be u of n minus 2. Now we have a very simple expression for our output. How are the output and the input related? Your output is x of n, that is the input, multiplied with u of n minus 2. Now by this time, whoever is practicing, whoever has gone through the subject, the moment they see an expression like this, they should answer about the linearity and time invariance. Now what we usually do for linearity is we apply the additivity and homogeneity, and then for time invariance you want to analyze, we can analyze. I will show you how to do this. Now I know a simple expression which is relating our output and the input. So we want to check the linearity. For linearity we need to apply the additivity rule. Suppose if I apply the input x1, the corresponding output will be, it is x1 into u of n minus 2. If I apply x2, then the corresponding output is the input, applied input into u of n minus 2. Now suppose if I apply a new input which is in the form of x1 plus x2, what's the corresponding output, students? It is so simple. This input multiplied with u of n minus 2. So that is x1 of n plus x2 of n, and then whole multiplied with u of n minus 2. You can clearly see that this expression is equal to y1 of n plus y2 of n, meaning by it obeys the additive nature. What next? Homogeneity. So let's apply our input of the form alpha into x of n. Let's see what's the corresponding output. The corresponding output is the applied input, that is alpha x of n into u of n minus 2. This can also be written as alpha times y of n. So when the input is multiplied by alpha, you can see the new output is alpha times y of n, meaning by it obeys homogeneity. This is definitely a linear system. Now how do you analyze the time invariance nature? Time invariance is always interesting, you know. So let us write the output input relation where the output is x of n into u of n minus 2. So there are some interesting things that we find for time invariance to check that. So one is delayed output. So how do you find delayed output? This is one of the easiest expressions where we replace n with n minus n naught. So this is called the delayed output. So the task is very simple, replace n with n minus n naught. So this gives you x of n minus n naught into u of n minus n naught minus 2. So let's keep this as a reference. What next? The next important thing is, what is the response due to delayed input? Okay, so it's called response due to delayed input. So in short, I'm writing like this. So instead of applying x of n, you have applied a delayed input. So how will the system respond if you apply a delayed input? And the expression for that is, it is x of n minus n naught into u of n minus 2. You can see clearly they are not same. Hence, this behavior is time variance behavior. This is time variance behavior. So what's the answer? A linear system, time variant system. So where is that option? Linear time variant. So this is the answer to this. I hope you have understood all these questions. So thank you for watching this.
Pre-gate solutions, control system for EEE. Right, first question. So they ask find the transfer function shown below. You go by any method, either block diagram technique or signal flow graph technique. The answer is same. Better go by SFG. Okay, na? So how many forward path? There is one forward path and there are 3 loops. This is L1. So here one forward path and this is one loop L1, this is L2 and this is third one is L3. Go by even Block diagram also same answer you will get it. Don't think that, but you should not simplify in the middle when you are solving by block diagram. You should write the terms as it is and then product and expand and solve it, same answer you will get. The best is what? SFG. So, how many forward paths? There is one forward path. So one forward. Use the Mason's gain formula. Mason's gain formula. Use the Mason's gain formula. So, transfer function equal to. So, what is the forward path gain? G1, G2. G1, G2 divided by loops. How many loops? The first loop, here positive feedback. So, what is the loop gain? G1 into 1 by G1, opposite sign minus. So, that means 1 minus G1 into 1 by G1, and second loop also same, G2 into 1 by G2, positive feedback minus G2 into 1 by G2. ठीक है ना? Next, third loop. What is the third loop? Tell G1, G2, H. Yes or no? Here negative feedback, positive. So, plus G1, G2 into H. Then again non-touching loops. L1, L2 non-touching. Positive into positive, positive only. So, plus. So, you have to write it here plus. So, G1, 1 by G1. G2 into 1 by G2. You solve it, you will get the answer. G2, G2 cancel, G1, G1 cancel. Here cancel. So, what is the answer we are getting? G1, G2 divided by 1 minus 1 minus 1 plus G1, G2, H plus 1. So, all these are cancel. Plus 2 minus 2 cancel. What is the answer? G1, G2 divided by G1, G2, H. G1, G2 cancel. What is the answer? 1 by H. Most of the people, they may think, they may do mistake in block diagram technique. Simple logic. First simplify the first feedback path, this one. You simplify, what I will get? What is the diagram tell here? R of S, here summing point. So, here what you will get tell here? G1 divided by 1 minus G1 into 1 by G1. Here what you will get tell here? G2 by 1 minus G2 into 1 by G2 you will get. Then C of S, then here negative feedback. Now again this two series now product it. A product what I will get? G1, G2 divided by 1 minus, you should not simplify, take the terms as it is. G1 into 1 by G1, this is one group, and again what? Second group is 1 minus G2 into 1 by G2. Then expand this. If you expand this product terms, G1, G2 divided by, if only product 1 minus G1 into 1 minus G1, yes or no? Then again if this product it minus G2 into 1 by G2, then minus minus become plus, then you product it G1 1 by G1, G2 1 by G2, 1 by G2. Yes or no? So, this is the term. Again it is having a unity negative feedback. That means if I write C of S by R of S, if I write G1, G2 by, all these terms as it is will come now, 1 minus G1 into 1 by G1 minus G2 into 1 by G2 plus G1 bolo, into 1 by G1, G2 into 1 by G2. Again feedback na, negative means plus. Numerator term, product, what is the numerator term tell here? G1, G2. Feedback gain H, here feedback gain H is there. Here feedback gain H and here into H. See, it is not unity feedback, it is H. So, now solve this 1 cancel, this cancel, this cancel, cancel. What is the answer? Same answer or not? G1, G2 by below 1 minus 1 minus 1 plus 1 G1, G2 H. So, all this cancel, what is the answer? 1 by h, same answer we will get. Okay, na? 1 by h is the answer. While going the block diagram techniques, anytime denominator going to be 0, don't make it 0. At the end, we make it cancel. Don't simplify in the middle. Right, next question. For the characteristic equation, find the k and tau such that the system has two roots at plus or minus J2. So, poles at plus or minus J2 means the system must be marginal stable. Given system must be marginal stable. Given system must be marginal stable. It should be marginal stable. So, write the characteristic equation. So, write the Routh array, RH, right. So, here S cube S cube, S square, S power 1, S power 0. S cube coefficient is 1. S cube is 1. Alternate k plus 2. Alternate k plus 2. Next, here S square is t. Next 1 plus k. Here it is 1 plus k. Then product it t into k plus 2 minus 1 plus k divided by t. Here what? 1 plus k. For marginal stability, so one time row of 0 should be there and also have same sign. I will make it this s power 1 coefficient 0. It gives marginal stable condition. Then this equation become auxiliary equation. This row gives the auxiliary equation. So now what is the condition we are getting? T equal to k plus 1 by k plus 2. If you make equal to 0, you find t, you will get this is the equation. Now what is the auxiliary equation? T s square plus 1 plus k equal to 0. S equal to j omega na, omega given 2 na. So substitute it. So minus 4t plus k plus 1 equal to 0. T equal to what? K plus 1 by 4. This is equation 2. 1 and 2 make equal. If you make 1 equal to 2, k plus 2 equal to 4, k equal to 2. K equal to 2 substitute, then t will become 3 by 4, means 0.75. 2 and 0.75 is the answer. 2 and 0.75. So, answer is B. Next. So, they given an Nyquist plot, open loop transfer function given. In the given open loop transfer function, one pole is right, P is 1. Number of poles in the right hand side, closed loop poles they are asking. So, here itself directly, this is the critical point, minus 1. This is minus 1. If you draw a line here, n about minus 1 equal to what? Minus 1. P is 1. P is 1. That means what? N about minus 1 not equal to P. Closed loop system unstable. So, n about minus 1 equal to P minus Z. So, minus 1, 1 minus Z. Z equal to 2 means 2 closed loop poles right. 2 closed loop poles right. So, answer is 2. Next, the output rate control used to improve the damping of the system given. If the closed loop system required to have a damping ratio of 0.5, then the value of K is. So, this K value they are asking. So, here first find the closed loop transfer function. First find closed loop transfer function. Find closed loop transfer function. So, what is the closed loop transfer function? First write the closed loop transfer function. Closed loop transfer function you find. closed loop transfer function. So, C of S by R of S equal to, so here 1 by S into 1 plus 4S. Na? So, 1 by S into 1 plus 4S, which is having a feedback, negative feedback. So, numerator product with this means plus Ks. Again series with what? 100. So, product with 100 means here numerator 100. Again we are having a what? Negative feedback means minus means here it become plus. So, you will get 100. So, that means closed loop transfer function is 100 divided by 4S square plus S plus Ks plus 100. That means what you are getting, tell? 100 divided by 4S square plus S, take it common. So, 1 plus K plus 100. Then what you are getting? Divided by 4 column, bring it to standard form, you divide into 4, means 25 divided by S square plus S into 1 plus K by 4 plus 25. So, now find omega n. Omega n equal to 5 radians per second. 2 zeta omega n equal to 1 plus K by 4. So, what is zeta we required? 0.5, na? Zeta 0.5 required. Omega n is 5 equal to 1 plus K by 4. So, that means 20 equal to 1 plus K. So, K equal to 19. Answer is 19 here. Next. So, the open loop transfer function of a system given with respect to root locus diagram, which of the following is correct, they are asking. So, break point you have to find and center of the circle. Root locus forms the circle here. What is the center of the circle they are asking? Okay, na? Right. So, break point. So, break point you have to find. How to find break point? First we need characteristic equation. 1 plus GH is equal to 0. So, what is the characteristic equation? Tell? 1 plus K is K into S plus 2, S plus 3 divided by S into S plus 1 equal to 0. Now, write K. K equal to, tell, minus of S square plus S expanded divided by S square plus 5S plus 6. Yes or no? This is the K. Now, break point means differentiate. Break point means dk by ds equal to 0. Break point means dk by ds equal to 0. Yes or no? dk by ds equal to 0. Now, differentiate, come on. dk by ds. So, take minus as it is. Now, u dash means 2s plus 1 into v s square 5s plus 6 minus u s square plus s into v dash 2s plus 5. Yes or no? Divided by v square s square 5s plus 6 whole square, make equal to 0. So, make equal to 0, then what you are getting here? 2s plus 1 into s square plus 5s plus 6 minus s square plus s into 2s plus 5 equal to 0. Now, expand it. Come on, 2s cube, expand it, 2s cube plus 2 into 5. 10 s square plus 12 s plus s square plus 5s plus 6 minus 2s cube plus 5s square, next plus, sorry, minus here, So here what happened? Minus 2s cube minus 5s square minus 2s square minus 5s equal to 0. What are the terms cancel? 5s is cancel, 2s cube is cancel. Next here 11s square, here 7 means 4. You will get plus 4s square plus 12s, here 12s left. Next here plus 6 equal to 0. You find the roots for this. You will get the 2 breakpoints. You find the roots. S1 comma S2 is minus, so 0.643 minus you will get 2.366 you will get. That means both are correct. Here if you draw RLD, how you will get L here? If you draw RLD, so here what happened? One pole at minus 1, one pole at minus, one pole at 0, one pole at minus 1, 1 0 at minus 2, 1 0 at minus 3, minus 3, minus 4. So we will get RLD circle because 2 poles, 2 zeros, leaving, entering. So here RLD is there, here RLD is there, here it leaves, here it enter. It forms a circle. Like this you will get. It forms the circle. This will be a break point. It is on the root locus branch valid minus 643 as well as this break point is minus, this is 2 kada. This is minus 2.366 minus. So both are correct. Option A correct, option B correct. Okay, both are correct. Next center is check it. Center is nothing but midpoint of break point. So minus 0.643 minus 2.366 divided by 2. Midpoint center is nothing but. So minus 3 by 2 will get. Center is minus 1.5. That means what happens? Center D. That means A, B, D. 3 options are correct. Next, so the differential equation given, they are asking state transition matrix. So differential equation, what is given? Y double dash plus 3y dash plus 2y equal to u given. So you required here number of state variables observed. I will solve in the next page better. So y double dash plus 3y dash plus 2y equal to u. So number of state variables are 2, n is 2. So let y equal to x1. Next y dash equal to what? x1 dash, that equal to x2. 2 state variables required. Y double dash equal to x2 dash. You substitute in the given equation. This is equation number 1. You substitute in the given system. You will get x2 dot plus 3 x2 plus 2 x1 equal to u. So if you write x2 dot equal to u minus 2x1 minus 3x2. This is equation number 2. Equation number 2. Now you write a state model. x1 dot x2 dot equal to, so x1 dot linked with what only? First x1 dot linked with, not linked with x1, so 0. So x1 dot linked with only x2, so 0 1. Here x1 x2 plus here input u. So x1 dot linked with only x2, 0 1 with input 0. x2 dot linked with x1 by minus 2, x2 by minus 3, input by 1. Y is linked with only x1. So that means 1 0. Y is linked with. This is the what? State model. We don't want state model. We want STM. Means we need A matrix. What is the formula for STM? STM pi of t. equal to what? E power minus at. E power minus at. That equal to what? Laplace inverse of simply Si minus A inverse. So that equal to, simply I told shortcut we can apply in the exam shortcut method. So adjoint of, shortcut means verification of properties. But here I will go by procedure. Si minus A. Okay, na? L inverse adjoint by this. Right. So here first you have to write Si minus A. Si minus A. So write Si minus A. Si minus A. So add S diagonally, opposite sign of coefficients. Opposite sign of coefficients. So here what happened? 0. Here minus 1. Here plus 2. Here plus 3. So this is Si minus A. So now write pi of t. Pi of t. Adjoint of Si minus A. So L inverse of adjoint means here S plus 3. Here it is S. Here it will become plus 1. Here it will become minus 2. Divided by det. Write the det individually. So what is that? S square plus 3S plus 2. 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 So now find partial fractions L inverse of. So here what I can write? S plus 3 divided by S plus 1 into S plus 2. 1 by S plus 1, S plus 2, minus 2 divided by S plus 1, S plus 2, S divided by S plus 1, S plus 2. Partial fractions and inverse Laplace transform. You find partial fractions and inverse Laplace transform. So, L inverse of, so find partial fraction. Minus 1 means here 2. 2 by S plus 1 minus 2. If you take it here, what happen? Minus 1 by S plus 2. If you take minus 1, 1 by S plus 1 minus 1 by S plus 2. If you take S equal to minus 1, minus 2 by S plus 1 plus 2 by S plus 2. Again take S equal to minus 1, minus 1 by S plus 1 plus 2 by S plus 2. If apply inverse Laplace transform, 2 e power minus t minus e power minus 2t, e power minus t minus e power minus 2t minus 2 e power minus t plus 2 e power minus 2t minus 1 e power minus t plus 2 e power minus 2t. This is the answer. If you observe the answer, you will get, I think it is B. The answer is C. Observe it. 2 minus 1 minus minus plus S. So answer is C. Check it. Okay.
Yes, see this question from DC machine. It is given that a 240 volt DC series motor is rotating at 1100 RPM by drawing a current of 10 amperes or 11 amperes with a negligible series resistance. If it is desired to operate a motor at 1000 RPM under same voltage and same current, then external resistance required in armature is dash. External resistance required in armature. Okay, so here this is the resistance control method only. Okay, resistance control method. 240 volt DC series motor rotating at 1100 initially with 11 amps, and given that negligible series resistance means total resistance of motor is negligible, means RA we have, RSA we have, that is negligible. Now see, solution for this is 240 volt DC series motor. 240 volt DC series motor. it is drawing a current of how much initially? IA1, 11 ampere, and rotating at 1100 rpm. Okay, then what is the back EMF here? As the resistance negligible, EB1 equals to V only, that is 240 volt only. Now we have to reduce, no? So we have to reduce, see the speed. If it is desired to operate motor at what speed? 1000 rpm. We have to reduce the speed to 1000 under same voltage and same current. Then external resistance to be added in armature is dash. Now we need to add some resistor in series with the armature under same voltage and same current, 240 volt series field winding, and under same voltage same current, no? That is voltage is IA2, now also voltage is same 240, IA2 also same 11 ampere, and some resistance we need to add so that the speed should be reduced to N2 equal to 1000 rpm. Now motor should operate at this speed. Now what will be the back EMF under this? EB2 equals to 240 minus 11 RE only. RE unknown for us. Okay. Now apply the speed relation. N2 divided by N1 equals to EB2 by EB1 into phi1 by phi2. What is flux in both cases? Flux proportional to armature current here. Flux proportional to armature current. It will be same in both. So it is cancelled. Then N2 by N1 1000 divided by 1100 is equal to 240 minus 11 RE EB2 divided by EB1 value 240. So only unknown is what here? RE equals to, simplify that, we get RE value 1.98 ohms it is. Okay, so this much resistance we need to add, 1.98. So it is numerical answer type, no? So 1.98 means around, according to options, it is what? 2 ohms it is. So 2 ohms is the correct one. According to options, 2 ohms is correct. Okay, 2 ohms is the answer. If it is numerical answer type, write whatever you got exactly. Don't round off to next digit. So exactly write 1.98 only if it is numerical answer. Otherwise here, if it is MCQ model, no, then you can take 2 ohms it is. Okay, next. Okay, see this question. This question is from DC machine only. Which of the following is or correct during commutation of a DC motor? Okay, commutation of DC motor. First option, the commutation can be improved by shifting brush in its opposite direction. The commutation can be improved by shifting brush in its opposite direction. Right or wrong? So commutation means spark we can reduce. Commutation improve means spark can be reduced. So we can improve commutation by shifting brush in its opposite direction. So opposite means opposite to motor. So this is correct only. A is correct. And next is reactance voltage will improve commutation. No. One of the reason for delayed commutation is reactance voltage. It will not improve commutation. This is wrong. A is correct. And resistance commutation is used for all ratings of DC motors. Yes. Resistance commutation means carbon brushes, high resistance carbon brush. We use for all ratings of motors. So this is correct. Spark always occurs at trailing tip of the brush. Yes. Generally, whenever commutator moving from one segment to other segment, we will get spark at brush. At which tip of brush we get spark is at the end of commutation. That's why at the trailing tip of the brush we get the spark. So here A correct and C also correct, D also correct. So A, C, D correct. Okay. See, next question is from transformer it is. In a star delta transformer with no load on delta connected secondary. No load on delta connected secondary. Okay. No load on delta connected secondary given. For rated sinusoidal supply to star, the shape of flux in the core under steady state is dash. the shape of flux in the core under steady state. See, star delta transformer is there, delta secondary no load condition, primary star supplied with a sinusoidal voltage. Then shape of flux in the core is dash. As delta is there on secondary, that may be no load or load, any condition. The shape of flux always in this connection is sinusoidal only. If delta is closed, okay, delta is there secondary, whether it is no load or load condition, the shape of flux is always sinusoidal only. Okay, option A correct for this. Sinusoidal it is. See this question. This question is on transformer parallel operation given. Read the question. Two transformers of ratings 300 kVA and 500 kVA are operating in parallel with a per unit impedance of 0.3 per unit and 0.2 per unit respectively. For a load of 700 kVA, the load shared by two transformers respectively dash. Load shared by two transformers. Okay, for the given impedance values. See, in order to calculate load sharing in per unit impedance values, we have to take one common base kVA first, because two transformers having different kVA here. One is 300, other is 500 kVA. Okay, so 300 kVA transformer having 0.3, 500 is having 0.2. See here, 300 kVA transformer is having impedance per unit is 0.3 per unit, and 500 kVA transformer is having impedance ZB equals to 0.2 per unit. Now let us take one common kVA out of this common. I'm taking 500 higher capacity, 500 kVA as common. So under 500 kVA, what is ZA new value? ZA new, because that ZA is for 300, but we need for 500. No? So according to formula, old value is 0.3 into new volt ampere 500K divided by old kVA rating is 300K. Now simplify this, we get 0.5 per unit it is. Okay, and ZB value already it is on 500. Now also 500 means same 0.2 per unit. So 0.5, 0.2 new. Now we need load shared. What is the load connected? Total load 700 kVA. For this connected load, how much load shared by two transformers? Let us find SA. According to formula, SL into ZB by ZA plus ZB. SL is 700 into ZB value 0.2 divided by sum of the two, new value and this ZA new and 0.2. 0.5 plus 0.2, 0.7. 2 by 7, it will be 2 by 7, no? So 100, 200 kVA we get it is 200. If SA is 200, then what is SB directly? 700 minus 200, nothing but 500 kVA. So SA 200, SB 500. Now check which option is correct. 200, 500 should be there, means here 200, 500. Option C is the correct one. Okay, option C is the right answer here. Option C is right for this. See this question. A three-phase delta connected 440 volt alternator has synchronous reactance of 5 ohm per phase. Okay, with negligible resistance. It is delivering a load of 20 kVA to a bus bar at 0.6 lagging power factor. So 20 kVA delivering it is. By keeping same excitation, if turbine input increases till the power factor reaches 0.8 lag, then it will supply a current of dash amperes. How much current it will supply? Okay, simple. Alternator connected to bus bar and constant excitation, steam supply increasing or turbine input increasing till power factor reaches 0.8 from 0.6, and synchronous reactance 5 ohm per phase. See here. So given a three-phase delta connected, no, important, this delta connection is there, delta connected 440 volt. So phase voltage, line voltage same here. Given synchronous reactance is how much? XS equal to 5 ohm per phase. 5 ohm per phase. And it is delivering how much kVA? 20 kVA to bus bar at 0.6 power factor given. This is the data given. Now accordingly calculate what is the current it is delivering. Current equal to kVA by root 3 VL. 20k divided by root 3 into line voltage. What is the line voltage? Same 440. Calculate this, you'll get current 26.24 amperes. This is the phase line current it is. This is line, but we need phase current for calculation. Then I phase equal to by root 3. 26.24 by root 3 is 15.15 amps we get. Okay, this is the phase current. Now initially where it is operating, 0.6 lagging, no? Then calculate how much EMF is induced at that time. EMF formula is what? Square root V cos phi plus IARA whole square plus V sin phi plus IAXS whole square. Substitute here, phase voltage same only because delta is there, that's why. Root of what is the phase voltage? 440 cos phi 0.6 whole square because R is 0 plus V 440 sin phi 0.8 plus IA is what? 15.15. XS is 5 whole square. Okay, no? Now calculate this, we get EMF magnitude, check, it is coming 502.6 volt it is EMF. So as excitation constant in the question, what is excitation given? Constant. By keeping same excitation, turbine input only increase. Means excitation constant means this EMF is almost constant. It will be constant, it won't change. Now till what turbine input increase? Till 0.8 lag. Right now 0.6 lag it is operating. So till 0.8 lag it reaches. Means then also EMF same according to formula. EMF same only, whatever is there previous. Now root of what is the new power factor? 440 into cos phi 0.8 square plus V sin phi 440 sin phi is 0.6 plus IA unknown now, XS value also same 5 whole square. And what is EMF here? That 5 previously we got, no, this one 502.6 502.6 square on both sides, then root will be cancelled. 440 into 0.8 square plus 440 into 0.6 plus IA into 5 whole square. Simplify this, we will get the value of IA from this 18.97 ampere. What is this current from the equation? Is phase current it is. But what is the question? Question is what? Then it will supply a current of dash. Supplying current means which current it will supply finally? Line current only. So you should give the final answer also line. Therefore, the line current equal to root 3 times of this. Then it will be 32.34 amps we get. Check this and check which option is correct. 32.34. 32.34. Option A is the correct one for this. Option A correct. Okay. See this question. This is from 3-phase induction motor. A 3-phase 4-pole squirrel cage induction motor driving a constant torque load at 1440 rpm. Okay, at 400 volt 50 hertz supply initially. If the supply frequency increased to 60 hertz by keeping voltage constant, then speed at which the load operates. Means motor speed we need to calculate. So which condition? Load torque constant condition, and important is initial 400 volt 50. But now frequency only increase by keeping voltage constant. Okay, only frequency here, voltage constant. Then under constant load torque condition, under constant load torque, we know load torque is proportional to under this V1 by F whole square into Ns minus N condition with respect to voltage frequency and speed relation. Load torque constant means this product of both should be constant. So voltage constant, no? Remove that. So 1 by F1 whole square into Ns1 minus N1 equal to 1 by F2 whole square into ns2 minus n2. Right now, what is the frequency initially? 50 Hertz, 1 by 50 whole square into what is the ns1 for 4 pole 50 Hertz? 1500 minus n1 where it is rotating? 1440 equal to 1 by f 1 by 60 square. For 60 Hertz, what is the synchronous speed? Yes, it is for 4 pole 1800 we get 120 f by p minus n2 is unknown. Simplify this, we'll get the value of speed, new speed is around 1714 rpm approximately. Around this we get 1714. Okay, now check what is answer. 1714. Option D is the correct one for this. Option D is correct. Okay.
Hello everybody. Right students, now we'll see pre-GATE 2026 power systems questions, video solutions. See here the first question from economic load dispatch. The incremental fuel cost curves of two generators in rupees per megawatt hour are given in figures. Two diagrams are given here. The total load to be supplied is 1000 megawatts. So the total power demand, right? PD, it is given as PG1 plus PG2 must be equivalent to how much? 1000 megawatts. 1000 megawatts. The maximum and minimum generating schedule generators are also given. The optimum generator schedule they are asking. See clearly, this is PG minimum of generator 1, PG maximum. This is PG minimum and PG max. See, for a maximum generation of 800 megawatt, the cost of incremental fuel cost of generator 2 is 800 only. But whereas for that one, the plant 2 is having very high cost. That's why if you take 800 megawatts at 800 rupees per megawatt hour, the overall cost will be less. Means as plant 2 cost is less, take maximum generation from that one. So we can take PG2 is equivalent to 800 megawatt and PG1 should be 200 megawatt for making 1000. But the problem here it is, they are saying that PG1 minimum is 300. So that it's not 200, you have to make it 300. So that even though its cost is less, you have to fix it for only 700 megawatt only. 700 megawatt only. So that PG1 is 300, PG2 will be 700 is the answer. It's already given in the options. Generator 1 is 300, generator 2 is 700. That's the answer. Very simple question only. Right. Coming to the next question, the magnetic inrush phenomena in a transformer is increased by increasing the residual magnetic flux. Yes, we know that the magnetic inrush phenomena, the flux always depends upon the residual flux. More the residual flux, more will be the flux demanded by the transformer, then the more will be the magnetic inrush phenomena. So that it is an MSQ, multi-select question. Option A is correct. And reduced by switching the supply at a switching angle of 90. Whenever you are switching the supply at alpha is equivalent to 90 degrees, the voltage V will become V max, and under this condition the residual the magnetic inrush phenomena will be less. The flux demanded by the transformer in this case will be very small. And reduced by the use of non-saturating transformer core. When there is no saturation for the transformer core, there is no magnetic phenomena at all, right? Because of the saturation only we are getting the magnetic inrush phenomena, right? So that second statement is correct, third statement is also correct. Reduced by switching the supply at a switching angle of 0, no. So it will be at 90, not at 0. So option D is wrong, right? So that A, B, C are correct. C are correct, right students? That is one question. And we will take one more question here. The relay used for the protection of alternator from failure of mechanical input. For mechanical input failure, simply we can say reverse power relay or watt metric relay we are going to use, right? And we will see the next question here. So these are the 2 marks questions we are having here. A single phase bundle conductor system with 2 subconductors
per phase is shown in the figure. So, this is conductor A, this is conductor B. The current in each phase will be equally shared by both the conductors. The inductance of each conductor they are asking. What is the inductance of phase A or phase B? As both are same only. We know that the inductance formula L is equivalent to 0.2 into Ln of GMD by GMR. GMD by GMR, millihenry per kilometer. Where GMR of one conductor is nothing but, we are having two conductors here, right. So, GMR of the first conductor multiplied with GMR of the second conductor under root, as two distance are there. Where GMR of the first conductor is nothing but D11 into D12 square root. It will be square root of D11 is 0.7788 into its radius is 0.05 meters into distance between them will be 0.3 meters. Right students, that is the GMR1 value. If you calculate this GMR1 value, already I have calculated that one, just I will give you the value here. So, it will be 0.108 meters. 108 meters. That is the GMR1 value. Right, GMR2 also same. GMR2 also same, and total GMR is also same. Total GMR is also same. And coming to the value of GMD students, the value of GMD, it is, so we have to calculate the equivalent distance from conductor 1 to the conductor A to the conductor B. The equivalent distance are A1 to B1 one distance, A1 to B2 one distance, B1 to A1, A2 to B1 one distance, A2 to B2 one more distance. Right? What are the distances? Distance from A1 B1, distance from A1 B2, distance from A2 B1, distance from A2 B2. How many distances? 1, 2, 3, 4, fourth root for GMR, geometric mean. So that it will be fourth root of A1 B1 students, A1 to B1, 0.3, 3. So it is 3.3 and then 3.6. 3.3 into 3.6 into A2 B1, 3 and 3.3. 3 and 3.3. So if you calculate this value, we are going to get this as 3.293. 3.293 meters. Substitute GMD and GMR values. The value of inductance is 0.2 into Ln of 3.293 divided by 0.108. So this will be, I am getting it as 0.683 millihenry per kilometer. 0.683 millihenry per kilometer. Like that we can calculate. That is one question. So that is in the transmission and distribution part. And one more question we can see here. So it is from the transient stability analysis, equal area criteria. A 50 Hz 100 MVA synchronous generator is having an inertia constant of 10 megajoules per MVA. So that inertia constant H is given 10 megajoules per MVA. Right. And capable of supplying 200 megawatt. So the maximum power it can supply, it is 200 megawatt. Right. Of power is connected to a large system and it is delivering only 100 megawatt. So that out of P max it is delivering only 100 megawatt, where PS is equivalent to electrical power is equivalent to 100 megawatt. When a three-phase fault occurs at its terminals, so when there is a fault at the terminals, so we have to clear the fault by using fast acting and auto reclosing circuit breakers. So in this case only P max 1 will be existed, there is no P max 2 and there is no P max 3. Then the time in which the fault must be cleared if the maximum power angle is to be 130. So that they have given delta max value as 130 degrees. 130 degrees. Right students. So here the apparent power is also given. S is given, it is 100 MVA, 100 MVA and frequency is given 50 Hz. These are the quantities they are given. They are asking what is the critical clearing time. The critical clearing time to be cleared to make the system stable, it is 2 into m divided by delta c, that is the critical clearing angle, minus delta naught, the initial load angle or initial rotor angle, divided by the mechanical power input PS. PS is, we know, 100. What about delta naught? The value of delta naught is equivalent to sine inverse of PS by P max 1. Where it is sine inverse of PS is 100, P max 1 is 200, it is sine inverse of 0.5, it is 30 degrees, which is 0.523 radians. Just for confirmation, 524 radians approximately, 524 radians. And delta max is given, how much it is? 130 degrees, 130 degrees. And its radian value will be approximately equivalent to 2.27 radians. 2.27 radians. Now substitute all these values in the equation, critical clearing angle equation, where delta C is equivalent to cos inverse of PS into delta max minus delta naught plus P max 1 cos delta max divided by P max 1. This is the formula. Substitute that values. The critical clearing angle delta C is nothing but cos inverse of PS is 100 into delta max radian value 2.27 minus delta naught radian value 0.524 plus P max 1 is 200 cos delta max degree value 130 whole divided by P max 1, it is 200. These are the values. Got it right? So if you substitute and calculate these values, you are getting 76.69 degrees and its radian value is 1.34 radians. So substitute this delta C value and delta naught value, radian values in this formula, you can get it. And before that, calculate m value. So m in radians, right? Electrical radians, where m is equivalent to S into H divided by pi into F. S is the apparent power 100 MVA, H is given 10 megajoules per MVA divided by pi is pi radians into F is 50, right? That is the value, right? You can substitute and then calculate these values. Therefore, the critical clearing time, students, you can calculate the critical clearing time value, TC. The critical clearing time is nothing but under root of 2 into, substitute this m value into delta C is 1.34 minus delta naught 0.524 divided by 100. So if you calculate this one, I am getting this value approximately, it has 0.322 seconds. 0.322 seconds is the answer you are going to get. And I think I got this value as 6.367, the m value. Just cross check that one. Like that you can calculate. This is the procedure you can calculate the critical clearing time. Right, students? We'll see one more question now. Yeah. So very basic question from the per unit systems, right? Converting into new base, change of base quantities problem. The figure shown below represents a generating station feeding power to 132 kV system. The base MVA for complete system is considered to be 100 MVA. So that entire network should be considered into 100 MVA. So here this is 100 MVA, this is 50 MVA, this is 60 MVA, this is 50 MVA, this is 60 MVA. So that there will be change of the base quantities. And base voltage is 22 kilovolts. There are change in voltage are also 22 kilovolts. Determine the equivalent impedance in per unit of the system seen from point F on the low voltage side of the transformer. So from this one, calculate the overall value they are asked. And the transmission line lengths are 80 kilometers. 80 kilometers. Right, students? convert generator 1 into actual new base value. What is that? Xg1 new value. Xg1 new value is nothing but Xg1 old value, Xg1 old value into S base new value divided by S base old value into V base old value divided by V base new value whole square. That is the formula. Where Xg old value is given 15%, this is 0.15 into S base new is 100, S base old will be 50 and V base old is 11, V base new is 22 whole square. Like that, you can calculate Xg1 value, calculate Xg2 value similarly. Xg2 new value is equivalent to same formula. It is old value is 0.1, 0.1 into S base 100 divided by 60 into 22 divided by 22 whole square. This is the Xg2. Similarly, calculate for transformer. For transformer, you can calculate on primary side or secondary side. Primary side old voltage is 11 and new voltage is 22. Right? New voltage is 20 on the primary side of the transformer. So, we can calculate for transformer. You can calculate for transformer Xt1 new value, where Xt1 new is nothing but Xt1 old value into S base new value divided by S base old value into V base old value on any side. On the same side, you can take the new value. So, if you are taking old voltage on primary side, new voltage is also primary side. If you are taking old voltage on the secondary side, new voltage is also secondary side. Right? You can see here, I am taking on primary side. So, old is 0.1, we can calculate old is 0.1 into S base new is 100, S base old is also 100 into V base old on primary side I am taking 11, new is 22, right, 11 divided by 22 whole square. Calculate this value. Similarly, calculate X22, calculate for the transformer T2. Here 50 is changing. For transmission line, in case of transmission line, what is the value of students? XL, the line reactance, XL per unit value, they have given the actual value. So, XL actual value, that is line 1 into actual value divided by base value. So, the base value if you calculate here, it is S base 3 phase quantity divided by V base line whole square, where actual value is given that 0.1 ohms into S base 3 phase value 100 MVA into 10 power 6 and line base voltage is 132 kilovolts here. So, you can calculate 132 into 10 power 3 whole square. Right? You can calculate the XL1 per unit values and XL2 per unit. Now, XL1 and XL2 are in parallel. Right? And finally, for the next transformer also we can calculate. For the next transformer also we can calculate. Right, students? So, calculate all the values, and we can take. So, this is for transformer 1 and generator 1. This is for transformer 2 and generator 2. These two will be in parallel, and calculate the parallel combination of these two, the overall reactance of the transmission line and the transformer reactance. So, I have calculated these, I am getting these values as approximately 0.24 per unit, right. So, from this point, whenever I am calculating all this, I am getting these two are in parallel, resultant 1 and resultant 1, I am getting it as 0.24 per unit value. That is the per unit value we are going to get it. These two are in parallel, add that one and add that one. That is the resultant values we are going to get, students. That is the very basic question. Right, students? Right. So, these are the questions we are having from power systems in the pre-gate. Right, students?
Right. Let us see the questions from measurement subject. The question here is, the multiplying power of the multiplier of a voltmeter is 10. So which is given? M is given, multiplying power. If the circuit voltage is 200 volt, which is given V. The voltage across the meter is dash. So what is asking? Vm they are asking. Very simple. In this, multiplying power or multiplying factor, M is equal to V by Vm. So therefore, Vm is equal to V by M. What is V? 200 by M is 10. So answer will be 20 volts. This is the answer. Right? Next question. The value of current through 10 ohm resistance in the following Wheatstone bridge is. What we require? Current through this resistance. Just by looking at this, don't get confused. Just observe the bridge balancing condition. Observe the bridge balancing technique. What is it? If you observe this entire circuit, this is perfectly balanced Wheatstone bridge. How to analyze, sir? Very simple. This node I am taking as A, this node as B, this node as C, and this node as D. Now I am redrawing the diagram. This node is A and B, this is A and B, this is C node, and this is D node. Okay. Now between A and B, 25 volts is there. Between A and B, 25 volts is there. Right. Next, A and C, 5 ohm resistance. A and C, 5 ohm resistance. A and D, 10 ohm resistance. A and D is 1 ohm resistance. A and D is 1 ohm resistance. After that, B and C is 20 ohm resistance. B and D is 4 ohm resistance. After that, between C and D, 10 ohm resistance is there. So this is the diagram. But they have not given this diagram, they have given in the other shape. That's it. You need to observe the given circuit is nothing but balanced Wheatstone bridge. How is it? 5 into 4 equal to 20 into 1. So therefore, what we can write now? 5 into 4. Yes, opposite branches multiplied equal to the opposite branches multiplied. Therefore, the bridge is balanced. Now, if the bridge is balanced automatically, what is the current through C and D branch? CD, that is 10 ohm. That is simply, what is the value? 0. So therefore, current through 10 ohms is 0 ampere. So what is the answer for this? The current through the 10 ohms is 0. That too, this will be clear only when you convert the circuit into the bridge circuit. After that, bridge is balanced, automatically 5 into 4, 20 into 1. Current through this will be 0. So these are the questions from measurement subject.
Okay, welcome to ACE Online. Let us solve some pre-gate analog questions. Go through the question. The op-amp is considered ideal and the output voltage V0 is 0 volts. So the output voltage V0 is 0 volts. Then the input voltage Vin is. Since there is negative feedback, you can apply virtual short. The current entering should be equal to current leaving. So let us apply KCL. If you consider this current as I1, I2 and I3. I1 equal to I2 plus I3. I1 is 0 minus Vin by 6K. I2 is 1 milliampere. Op-amp draws no current. Vin by 3K. So, your V in is going to be something like 6K parallel with 3K. So, it is 2, I think minus 2 volts. Option D is the right answer. The Zener given has a 5 volt breakdown voltage, VB is 0.7 for NPN and VEB is 0.7 for PNP. So, there is 0.7 here for NPN, 0.7 here for PNP. Now, find V0 and I0, V0 and I0. You can see 10 minus 0.7, you have 9.3 here. 5 minus 0.7, you have 4.3. I0 is going to be 4.3 by 0.86K. And what is V0? V0 is the difference. V0 is 9.3 minus 4.3, which is 5 volts. Now, before we calculate I0, just to see in the 4 options, if there 2 options are there with 5, no, there is only one option with 5, there is no need to calculate I0 also. Your V0 is 5, but of course, your I0 is going to be 4.3 by 0.86, which is 5 milliampere. The diodes are given ideal and the waveforms are also given. Oh, we have to recognize which option is correct. Which option is correct? You can see during positive cycle, the diodes are on. Let us assume this as node A and node B. If current flows from A to B, it is positive. Current flows from B to A, it is negative. So, during the positive cycle, current is flowing from A to B, so you get positive. In the negative cycle, the diode will not allow, so you are not going to get anything here. So, that means this is correct. What happens in the second option? In the second option, during positive cycle, upper diode is on, current will flow from A to B. So, you get positive. In the negative cycle, current D2 is going to be on, current will flow from B to A, you are going to get negative. So, the same output, there are 2 paths for the current, positive cycle D1 is on, negative cycle D2 is on. This is also correct. Third option, during the positive cycle, current cannot flow. This is current has to flow from plus to minus. So, current cannot flow from cathode to anode. So, no output is there. So, this is A and B. But what happens in negative cycle? In negative cycle, current has to flow in the opposite direction. But when it flows, you can see that it is choosing a path from A to B. I told you if current flows from A to B, it is positive. Current flowing from B to A is negative. So, though you give a negative cycle, you are going to get only positive here. So, this is correct. And the fourth one, during positive cycle, no current will flow. During negative cycle, current will flow, but now it is flowing from B to A. So, you will get negative. Oh, all options are correct, but only few. Oh, here we can see option D, all options are correct is given. So, that is the right option. The transistors Q1 and Q2 are biased at DC current of 1 milliampere, beta is given, Vt is also given, beta is 100, Vt is 26 millivolt, IC/DC is 1 milliampere. So, GM is IC/DC by beta by GM is R pi, beta is 100, GM is 1 by 26, it is 2.6K. Now, let us come back here. Now, why did I calculate R pi? Because he is asking you to find the input resistance at the base terminal. We know in BJT at the base terminal you have a resistance of R pi. At the emitter terminal it is R pi by 1 plus beta. So, this is base terminal, or if you want you can have an NPN equivalent for this, or NMOS NPN equivalent. So, this is your Q2 and here you are going to have Q1. Here you can see collector is shorted to emitter. Collector is shorted to emitter. So, what is the input resistance? Input resistance is given as V in by I in, which is VB2 by IB2. R in is going to be V in by I in, VB2 by IB2. It is R pi, 2.6K. Option C. Input is given to base terminal. The resistance seen at base is always R pi. The given MOSFET works in saturation with mu Cox W by L, mu Cox W by L, K is 2 milliampere per volt. Op amp is considered ideal, there is negative feedback. Your V in is given as cos square T. Threshold voltage Vt is 1 volt. What is that we have to find here? Find V naught. V naught. Now, this V naught is simply negative of VGS, because 0 minus VGS is V naught. So, your V naught is minus VGS. This is the answer. But what is VGS if the MOSFET is in saturation? This is virtually short. The drain current here, this is the drain current. Op amp draws no current, so this is also the drain current. The drain current is V in by 1K. V in by 1K. So, let us substitute now. In saturation, ID is K times of VGS minus VT whole square by 2. So, let us substitute and find V naught. ID is V in by 1K. K is given as 2 milliampere per volt. Vt is 1 volt. So, V in is going to be VGS. VGS is nothing but minus V naught minus 1 whole square. So, what is V naught? Minus V naught minus 1 is going to be root V in. Root V in. So, your V naught is going to be root V in minus 1. Root V in minus 1. So, what is V in? V in is cos square T. So, it is cos T minus 1. V in is cos square T, so it is cos T minus 1. I am getting A option minus, okay. So, here a small correction here, you can see your V naught is this. So, your V in is going to be minus of this. Your V naught, there is a negative sign here, goes there plus, so it is minus of this. So, minus of cos T plus 1. So, option A. Thank God there is no other wrong option. Luckily, I had to recheck. So, minus of cos T plus 1 is the right answer. Okay? Okay, then my best wishes to you. Do well in the exam. Good luck.
Well, pre-GATE 2026 digital electronics from electrical paper. In the synchronous counter shown in figure, ignore the propagation delay of logic gates and flip-flops. So, initial values are provided 0, 0. And the number of binary states producing by the counter. So, indirectly this is a question for modulus number, right. So, if this is 0, second one is T flip-flop, first one is a D flip-flop. So it is just a transparent flip-flop whenever the clock is available. And the second flip-flop, t value 0, it will preserve the previous data. You know, if t value is 1, for the clock excitation, output will be toggles. So now the initial output 0 0 at Q1 and Q0. Output of T flip-flop is 0. So what is the input of D flip-flop? Available input is 0 now. What is the 0 complement? This is 1. If you apply the clock pulse, 0 will transfer, but at the same time, given is a synchronous counter, simultaneously they can take the decision, right? So simultaneously the second flip-flop output will be toggle because of this 1 at T. So that after clock, this is 0. Because of this 1, output will toggle. Toggle means 0 complemented as 1. So now the available data. Available data at Q1 is 0. Available data at Q0 is 1 now. This is 1. If this is 1, this is also 1. We have to update the data, okay? So still output of first flip-flop is at 0. What is the 0 complement? 1. So this time if you apply the clock, 1 will transfer. At the same time, because of this 1, output of T flip-flop will be toggle. So if you apply the clock, this is going to change as logic 1. At the same time, output of the second flip-flop will be toggle. Toggle means 0 complement. 1 complement 0. So 0 will be overwriting by 1. So that what is the updated data? 1 0. And you consider this 1 0 as a fresh data. Output is already 0 here. And this is 1. What is the 1 complement? This time this is going to be 0. As this is 0, feedback line is 0 now. We can take it as a separate table, but we can do it on circuit itself. What is the D flip-flop input? 0. What is the T flip-flop input? 0. Input is 0, output will preserve after clock. Input is 1, after clock 0 will transfer to the output. So that if you apply the clock, next updated value is 0 only, but here as D flip-flop is a transparent flip-flop, next updated data is going to be 0 here. So that 0 0. What is a 0 0? 0 0 is the initial data. So that 0 0 0 1 1 0. It is a mod 3 counter, or it can give only 3 states. B is the correct option.
Hello everyone. Let us now discuss the questions from subject power electronics. The first question: if the power rating of driver circuit of an IGBT and BJT are compared, then the following statement is true. He is comparing the driver circuit power rating in IGBT and BJT. We know in case of BJT is a current control device. The base current controls BJT's operation. The value of my base current in practical case will be in some amperes or some fractions of the ampere. But whereas if I compare the IGBT is a voltage control device, and because of the silicon dioxide layer, that is SiO2 layer, check the construction of IGBT. Between gate and your remaining structure of IGBT, we are having a dielectric medium, that is a SiO2 layer. Because of SiO2 layer, my driver circuit current in IGBT is very small. It is in the range of nanoampere. And because of that nanoampere current in a driver circuit in IGBT, whereas in BJT, my driver circuit current is a base current. If I compare the driver circuit current in BJT, it is a comparatively more than that of my IGBT driver circuit current, right? So here in case of IGBT, my driver circuit current is IG, which is in the range of nanoampere, right? IG is in the range of nanoampere. It is less than in BJT, my driver circuit current is a base current. Driver circuit current is a base current. Now this current value is very small. It is in the range of nanoampere. Because of this, my power rating of driver circuit in IGBT is very small compared to that of my BJT. So your suitable answer is a power rating in IGBT is less than power rating of driver circuit in BJT. They are comparing the power rating of a driver circuit, that is nothing but control circuit power rating. Okay. So correct answer is power rating in IGBT is less than power rating in BJT. So option C is the correct option. Alright. Next. Yes, next question. A single phase half bridge inverter controls the power in a resistive load. They are saying half bridge inverter, right, and resistive load. The input DC voltage to inverter is a 220 volt, Vs is 220, and a uniform pulse width modulation with a 5 pulses per half cycle is used. Uniform PWM means your multiple PWM. Number of pulses per half cycle is 5. For output voltage of 100 volt, the width of each pulse in a degree is, they are asking what is the width of each pulse. Okay. So this question is related to the half bridge inverter. Yes, single phase half bridge inverter, single phase half bridge inverter, right? It is given that Vs is 220, multiple PWM, multiple pulse width modulation, number of pulses per half cycle is equal to 5, and our task is to find the for output voltage of 100 volt. By default, output voltage of an inverter is nothing but RMS value. Inverter input is a DC, output is AC. So for AC quantity, by default given voltage, given value is a RMS value. So V0 RMS is equal to 100 volt, is equal to 100 volt, right? Next, now they are asking what is the each pulse width, that is 2D by N. Width of each pulse they are asking, that is 2D by N. Alright. So here now I can write for multiple PWM. What is the V0 RMS we have written? Recall multiple PWM. V0 RMS is under root N into 2D by N upon pi into Vs by 2. Now here half bridge inverter. So input voltage is Vs by 2. Right? Vs by 2. Now this V0 RMS is 100, which is equal to under root N is 5. 2D by N we need to find, that is width of each pulse upon pi. Yes, into Vs by 2, that is a 220 by 2 means 110. From this you will get a 2D by N, that is the width of each pulse, right? Simplify this, you will get it as 29.75 degree. 29.75 degree, right? So correct answer is 29.75, width of each pulse. Alright. Next. Yeah. This is 2-mark question. In a 3-phase fully controlled rectifier, 3-phase full converter given, 6 thyristors. Shown in the figure, the instantaneous DC link voltage, instantaneous output voltage, DC link means output voltage, output side voltage is DC, right? When devices T1, T2 and T3 conduct is, yes, so here they are saying when T1, T2 and T3 conduct, then what is the instantaneous output voltage? And 4 options he has given. Okay, let us discuss now. This is a source inductance present here, right? Source inductance. So we need to take the help of effect of source inductance on 3-phase full converter, right? Now, if you recall, we have written one point. Due to the source inductance during the overlap angle mu, 3 thyristors will be in a conduction mode. So here it is given T1, T2, T3, these 3 will be in a conduction mode. Then during that overlap angle mu, what is the output voltage? Output voltage is the average of 2 line voltages. So average of 2 line voltages means your output will be either VAB plus VAC by 2 or VAC plus VBC by 2. Out of these two, you will be getting any one option is the correct option. Option A and option D will not be having relation with this question. In a 3-phase full converter, effect of source inductance during overlap angle mu, output voltage is the average of the 2 line voltages. So your answer will be either B or C. Let us discuss which one is correct now out of B and C. So for that here, yes, I am redrawing this circuit. Effect of source inductance is present here. Yes. This is a neutral point, VAN, VBN and VCN. Source inductance LS, thyristors T1, T3, T5, T4, T6, T2. Load is RLE and load current is constant, right? Load current is a constant. Yeah. Suppose current in this is my phase A. So I am writing this, I am taking this current as IA. Phase B current, let me take it as IB. And phase C current, let me take it as IC. IC, right? IA, IB and IC. Three currents we are having, phase currents, right? Now here it is given that T1, T2 and T3, T1, T2 and T3 are in a conduction mode. So what happens here? Without source inductance, if you recall the circuit operation, without source inductance, at any instant of time only two thyristors conduct, right? So initially here, suppose T1 and T2 are in a conduction mode, T1, T2 are in a conduction mode, and now you are applying the gate pulse to T3, you are applying gate pulse to T3. So what happens here? When T1, T2 conduct, your current will be flowing like this, VAN, LS, T1, load, T2, LS, VCN and again back to the phase A. Like this current will be flowing. No doubt, perfect operation. Your phase A current IA will be equal to I0 and IC equal to minus I0, right? IA is I0, IC is minus I0, no doubt. Now, you are triggering thyristor T3. You are triggering thyristor T3. So what happens here? Because of source inductance, for the overlap angle mu, my thyristor T1 current will start decreasing slowly. Thyristor T3 current will start increasing slowly. So during overlap angle mu, what happens? My T1, T3 both thyristors will be in a conduction mode from upper group, and from lower group only T2 will be in a conduction mode. Only T2 will be in a conduction mode. So here during overlap angle mu, during overlap angle mu, these three thyristors will be in a conduction mode, T1, T3 and T2. So can I write here KCL at this point? Suppose this is my node X. If I apply KCL at the node X, what I will be getting? IA plus IB. IA plus IB equal to I0, right? IA plus IB equal to I0. Load current is constant, right? Now differentiate this with respect to time. Differentiating with respect to time. So what will be getting? DIA by dt plus DIB by dt is equal to DI0 by dt. But load current is constant. So what is this differentiation? Differentiation of constant term is 0. So therefore we will be getting this term as a 0. So from this I can write DIA by dt plus DIB by dt equal to 0, right? So what is can we write from this DIB by dt is equal to minus of DIA by dt. Consider as equation number 1, right? DIB by dt equal to minus of DIA by dt, equation number 1. Now, if you check this branch, check between neutral point and phase A, that is VAN LS T1, this branch, and VBN LS and T3, this branch. These two branches, check. This branch, let me use different color. I am saying this branch from here to here. This is the one branch, is this upper branch. And this branch, VB1, LS and T3. These two branches are parallel, na? These two branches are parallel. We know voltage across parallel branches is equal, right? So now I am writing voltage across parallel branches as voltage across parallel branches is same. Voltage across parallel branches is the same. So now I can write, yes, what is the voltage across this branch? VAN LS. That voltage will be VAN plus LS into DIA by dt, not plus minus, current direction like this, okay. So plus VAN minus LS into DIA by dt. VAN minus LS into DIA by dt. That voltage should be equal to, yes, VBN minus LS into DIB by dt is equal to VBN minus LS into DIB by dt. Now further replace this DIB by dt with a minus of DIA by dt, right? Minus of DIA by dt. So I can write here VAN equal to, or VAN minus LS into DIA by dt equal to VBN minus, replace that DIB by dt with minus of DIA by dt. So if I put minus, that will become plus here, LS into DIA by dt, because equation 1. Because equation 1, right? So from this I can write VAN minus VBN equal to 2 into LS into DIA by dt. 2 into LS into DIA by dt, right? So from this I can write DIA by dt into LS is equal to VAN minus VBN upon 2. Consider as equation number 2, right? So I written expression for LS into DIA by dt in terms of phase voltage difference and divided by 2, right? Further, now our task is to find the V0 na, V0. V0 means voltage at this point minus voltage at this point, right? Now can I write voltage at this point is equal to VAN minus LS into DIA by dt. Check, potential difference between this point and this point will be equal to VAN, neutral point I am taking it as 0, right? So it is VAN minus LS into DIA by dt, that is upper terminal potential, okay. So VAN minus, now I am writing V0 equal to VAN minus LS into DIA by dt minus, what is the potential at a lower terminal? Potential at this lower terminal will be VCN, yes, minus LS into DIC by dt. VCN minus LS into DIC by dt, okay. So here VCN minus LS into DIC by dt, that is, this difference is nothing but my V0. But what is the IC? If you check here, whatever current here, same current is flowing through T2, and that is nothing but my minus IC. Check, from this circuit can I write my IC equal to minus I0? How current is coming? From this circuit branch current is coming, from this circuit branch also current is coming, and here those two currents are getting added. The same load current will be flowing through T2 into phase C. So my IC equal to minus I0, IC equal to minus I0, right? So now if I replace that IC with minus I0, I will be getting it as VAN minus LS into DIA by dt minus VCN minus, replace IC with the minus I0, so plus LS into di0 by dt. But what is di0 by dt? I0 is constant. So di0 by dt will be 0 na? That will be 0. So from this I can write V0 equal to, therefore V0 equal to VIN minus, what is Ls into dia by dt? Check. Ls dia by dt VIN minus VBN by 2. Right? So I can write here VIN minus VBN by 2 and minus VCN, right? Minus VCN. From this I can write it is equal to VIN by 2. Check. VIN minus VN by 2, that is VN by 2, plus VBN by 2, right? And minus VCN. Further I can write this as VIN minus VCN by 2 plus VBN minus VCN by 2. Check once. This minus Vs I have given as minus Vs by 2 minus VCN minus VCN I have given as minus VCN by 2 minus VCN by 2. Check, both terms are same only. But what is VN minus VCN? VAC. So it is equal to, I can write V0 equal to VAC by 2 plus VBC by 2, that is equal to VAC plus VBC upon 2. So when T1, T2, T3 conduct, my instantaneous output voltage is VAC plus VBC by 2, right? So check the options. VAC plus VBC by 2. Option C is the correct option, right? Correct answer for this question is option C. Right. Next question. Yes. A voltage commutator chopper. Voltage commutator chopper. Important question. Voltage commutator chopper bit is very, very important. Repeatedly they ask the questions. Yeah. Has the following parameters. Vs is 220 volt. Commutation circuit parameters L given, C given. On time of main thyristor given. And periodicity given. For a constant load current of 80 ampere. Load current is constant. The average voltage across the main SCR is. So they are asking what is the average voltage across main thyristor. If you recall, the voltage across main thyristor, that is VT1, or you can write VTM. VTM, voltage across main thyristor. How is the waveform for VTM? Yes, this is 0, T1, T2, recall circuit operation. Till T2, my main thyristor will be in on state only. Okay, check during our classroom sessions to discuss. This T2 is nothing but it is a point at which we are triggering the auxiliary thyristor. When I trigger auxiliary thyristor, my main thyristor will turn off immediately and voltage across main thyristor will suddenly increase to minus Vs. After that, we will be having this type of wave shape. Please check this waveform we already drawn during our sessions. And from this point to this point, it is like your VT1 is a Vs. After that, it is same. So this voltage is Vs. This voltage is minus Vs. If you recall, this time we have indicated with the TC. Circuit turn off time for main thyristor, right? Circuit turn off time for main thyristor. Now, this is linear, na? So if this is TC, this time also is TC. TC. This is linearly increasing from minus Vs to plus Vs. So time taken by your this VTM waveform to move from minus Vs to 0. If this time is Tc, then 0 to plus Vs, the time will remain again Tc. Now they are asking what is the average value of the voltage across thyristor. Average means area upon periodicity. Area upon periodicity. if you check this waveform, here whatever area under this, same area you are getting here, yes or no? This area both are equal opposite. So during this interval till T4 my resultant area will be 0. Till T4 my resultant area will be 0. So if I want to find Vt average, simply I need to find this area and divide with the periodicity. What is this area? It is Vs into T minus T4. Yes or no? Vs into T minus T4. And periodicity is a capital T. So I am writing here Vtm average is equal to Vs into T minus T4 upon capital T, total time T. Now it is Vs into T minus T4. What is the T4 indicates? If you recall the circuit operation, 0 to T2 time, this time indicates my T on, that is on time of main thyristor, that is T on they have given here. This T on time is nothing but 0 to T2 time. So this is T on, this is TC, this is TC. So 0 to T4 time indicates my T on plus 2 TC, T on plus 2 TC, right? So I am writing that T4 is a T on plus 2 TC upon periodicity is T. So it is equal to Vs into, now you can simplify this, T minus, what is T on? 800 microsecond they have given. Let me write it as it is first. Minus 2 TC, TC for voltage commutation, it is a C into Vs by I0 upon periodicity is T, right? Upon periodicity is T. Now you can put the values. What is Vs given? 220 into T 2000 microsecond minus T on 800 micro minus 2 into C Vs by I0. C is a 50 micro. Vs 220 upon I0. Load current is 80 and divided by 2000 micro, right? 2000 into 10 to the power minus 6, right? 10 to the power minus 6. We can simplify this. After simplification you will get it as 101.75 volt. This is a Vtm average. Average voltage across main thyristor. Okay, right. For this question, but you need to recall the circuit operation, right? Next. Yes. A buck converter shown in figure A is working in a steady state. Output voltage and the inductor current can be assumed to be ripple free. Figure B shows the inductor voltage during a complete switching cycle. Figure B shows the inductor voltage during the complete switching cycle. Assuming all devices ideal, the average voltage across the diode. They are asking what is the VD average. What is the VD average they are asking, right? Average voltage across the diode. Yes. Now if you check this question, here inductor current is a constant, means inductor conduction is a continuous. Conduction is a continuous. Now when switch is in a on state, this is a buck converter. When switch is in a on state, what is VD? VD equal to Vs. Switch on, at that time diode off na. So what is VD? VD equal to Vs, right? VD equal to Vs. And when switch off state, then inductor discharge and then your diode will be in a conduction mode. When diode conduct, what is VD? 0. So my VD waveform will be like this. VD waveform will be like this. Zero, T on, T. 0 to T on switch on, voltage across diode is a Vs, and T on to T diode is in a conduction mode. So this is my Vs now, voltage across diode. After this T, same cycle will repeat, right? Yeah. Now what is VD average? VD average equal to area upon periodicity na. So it is T on into Vs upon T. But T on by T is a D. So it is a D into Vs. D into Vs. So for finding VD average, we need to find duty cycle and supply voltage. How to find the duty cycle and supply voltage? Let us check. Now here they have given the voltage across inductor plot. Tell me during 0 to T1 when switch is in on state. When switch is in on state, diode will be in off state. What is voltage across inductor? Vs minus V0. During 0 to T1, voltage across inductor is a Vs minus V0. So here I am writing during T on VL equal to Vs minus V0. But that VL given 30 volt. So 30 equal to Vs minus V0. Consider as equation number 1. Right? Next, during off time of switch, when switch is in off state, what happens? This diode will start conduction because inductor starts discharging. At that time, what is VL? VL is a minus V0. Right? VL is a minus V0. So during T off, VL equal to minus V0. Recall in our classroom sessions we have written all these things, right? Now what is VL during off time? Minus 10. So minus 10 equal to minus V0. So from this I can get V0 which is equal to 10 volt. So output voltage is 10 volt. Now put this V0 here in equation 1. So therefore from 1 we can get it as 30 equal to Vs minus V0, but V0 is 10. So this will give me Vs which is equal to 40 volt, right? Supply voltage 40, output voltage is 10 volt. Now can we find duty cycle? D equal to V0 by Vs, right? In a buck converter, V0 is a D into Vs na? V0 equal to D into Vs. So D is a V0 by Vs which is equal to 10 by 40. That is equal to 1 by 4 means 0.25. D is a 0.25. So what is VD average? Therefore VD average is a D into Vs, that is 0.25 into 40. That is equal to 10 volt, right? It is equal to 10 volt. Correct? Yes. So simple question actually. Next question. Yeah. In the given rectifier, the SCRs T1 and T2 are triggered at a firing angle alpha 60 degree. They have given rectifier with the 2 thyristors and 2 diodes and load is highly inductive. If the input voltage is a 100 into sine of 100 pi t volt, the average voltage across load is, they are asking V0 average. V0 average. Tell me how will be the V0 waveform for this circuit. First during 0 to pi Vs positive. Vs positive means polarity. Here plus, here minus na. Which devices become forward bias? Thyristor T1, T2 forward bias. Right? So when at alpha, when I trigger T1, T2, current will flow like this. Vs, T1 load, T2 back to the Vs. Output voltage I am getting it as a Vs. So check alpha to pi. I am getting V0 equal to Vs. During alpha to pi, this is omega t 0 alpha pi and 2 pi. Yes, alpha to pi thyristors T1 T2 conduct V0 equal to Vs. T1 T2 conduct V0 equal to Vs. After pi what happens? Supply voltage is negative. Supply voltage negative means supply voltage polarity will reverse. That will become minus here plus here, right? When supply voltage polarity here plus here minus, then what will happen? Your inductor will be discharging. Inductor will maintain current in same direction. It will discharge like this. L, please listen. L, D2, Vs and D1. In this loop your inductor will discharge. Because when Vs negative, what happens? D1, D2 will become forward bias na? So these two will start conduction immediately. From pi to 2 pi only these two will conduct. inductor will discharge like this, and when these two conduct, check the supply voltage will appear as a reverse voltage for T1 and T2. So my T1 and T2 will turn off. T1, T2 will not conduct now. So what is output voltage during pi to 2 pi? Positive connected to positive, negative connected to negative. So V0 will be same as that of the supply voltage. So it is a but positive pulse, be careful. V0 is Vs means output voltage will be positive. After 2 pi, supply voltage is now positive again. Supply voltage positive means polarity will be here plus, here minus. So this supply voltage will try to turn off diodes like this. But if diode turn off, this current will drop to 0. Inductor will not accept that. Inductor will discharge. Tell me how many paths are available for the inductor to discharge during 2 pi to 2 pi plus alpha or 0 to alpha. Only one path available. Inductor will discharge only through D2, Vs and D1. During this interval, it will discharge through D1, D2 only, and in opposite to that of the supply voltage. So we will be getting output voltage which is equal to negative pulse. It is like this. So this is my output voltage waveform, right? Let us mark the conduction sequence of devices. Alpha to pi, which devices conduct? T1, T2. Pi to 2 pi. Diodes D1, D2. And in continuous cycle operation 0 to alpha also only D1, D2 conduct. 0 to alpha also D1, D2 conduct, right? What is V0 average for this? V0 average equal to, yes, I can write it as 1 by 2 pi integration alpha to pi. It is Vm sine of omega t d omega t plus integration from, here I am writing pi to 2 pi plus alpha. Instead of 0 to 2 pi, I have taken interval like alpha to 2 pi plus alpha. Means in continuous cycle operation, the 0 to alpha pulse will appear here during 2 pi to 2 pi plus alpha. Okay. So that value is now minus Vm. Output voltage is opposite to that of the supply voltage. Yeah, now simplify this. It is equal to Vm by 2 pi integration of sine minus cos. So put the limit directly. Minus cos pi plus cos alpha. Integration of sine minus cos, minus minus will become plus. So cos of 2 pi plus alpha minus cos pi. Minus cos pi. So it is equal to Vm upon 2 pi minus of minus 1 plus cos alpha. Cos of 2 pi plus alpha, cos alpha minus of minus 1. So it is 2 plus 2 cos alpha. So I am taking 2 common. 2 Vm by 2 pi into 1 plus cos alpha. Right? 2 to cancel out, it is Vm by pi into 1 plus cos alpha, right? Right. So put the value now. Vm is 100, supply voltage peak value 100. So it is 100 by pi into 1 plus cos of alpha. Alpha is a 60 degree, right? You can check this, you will get it as 47.74 volt. This is my V0 average, right? Average output voltage. Yes. So friend, these are the questions from power electronics.